You're listening to the Common Descent Podcast.
Hello, David.
Hello, Will.
And hello, listeners. Welcome to episode 203 of the Common Descent Podcast. This episode, we are discussing rodents.
Well, because we're really excited about tiny things this month.
Yes, evidently. We are on a theme. Rodents, a topic long overdue.
Yeah.
As many people have pointed out.
They're pretty common.
When I've told the couple of friends that I've told what episode's X, a few of them responded, "You haven't done rodents?"
Yep, almost 8 years. This is it. We've been waiting.
Rodents, very cool group of mammals. Very, very, very diverse group of mammals. This will be the barest overview of this group to get an idea of what it means to be a rodent, what some of the range of their diversity is, and the features we see in this group. We will not be diving into individual groups. In fact, the request list that we're about to read is only for rodent.
Yep.
If you wanted a specific one, we're saving those for later.
There'll be another. This is like what we did with dinosaurs.
Yes. We'll go through the modern diversity and what it means, what defines a rodent. We'll also go through the fossil history and some of the diversity and features we see in the fossil record that we don't see today. And as already mentioned, we're talking about this because it's about time, but mostly because it was requested.
By who?
This episode was requested by Mayara, Jamie, Daria, Lydia, Kyla, Taterboy 11, Alex, Cameron, Lewis, Julian, Sophie, Sarah, Jamie, Lucas, Justin, Hadley, Big, Noah, and E.
A whole swarm of them.
Yeah, we got a decent list here. And
Thanks,
once again,
everybody.
this is just rodent.
Just for rodents. More specific requests and future episodes.
There's plenty of those already waiting. Before we get into our main topic, some quick announcements. First and foremost, we have a Patreon. And our Patreon funds the podcast top to bottom. Without it, we would not be able to do all the things we do and that you enjoy for us to do. You can get lots of goodies and extra benefits when you join us on Patreon, from extra recordings, extra behind-the-scenes info, live streams with us. And at certain levels, you can get your name shouted out. So welcome to some of our new patrons, Aaron, James, Damon, and Nick.
Welcome and thank you for your support. We really appreciate the support that we get from each and every one of our patrons.
Absolutely. Another bonus thing that's going on right now, since we are at the end of October, is spooky season.
It has been spooky all October. Tiny monsters.
Tiny monsters.
And we're almost done.
Yeah. All 4 of our spooky episodes are done. Now we have QT and a live stream next month on the 9th.
So November 9th, join us on YouTube. For anybody is welcome to join, and we'll talk about all sorts of spooky stuff.
Yeah, so if you have questions or ideas about any of the spooky monsters, the tiny monsters we went over this month, join us there and share your thoughts with us. Also, keep your ear out. Spotlight is still going on. So there's a new episode coming out next month, first Wednesday. And next month on the 1st, we will be releasing the questionnaire for the end of the year Q&A.
Every year, we like to wrap it up with a giant Q&A where we answer as many questions as we can from our listeners. This year, that question submission form will just be open all November.
Yes. We figured that was just a simple way to keep track of when it's available. You can submit any kind of question you have.
Science-y, not science-y, silly, whatever you want.
And then we will sit and record for however long it takes to get through however many questions you all submitted and release that at the end of the year to wrap up the year.
Should be good. The end of the year Q&A is always so much fun. We get a ton of great questions. Hey, before you wrap up the announcements and move on to the news, there's one more thing that I have to say, and that is our friends over at Eons, their podcast is back.
Oh, yeah.
So here, I'm going to read about the Eons podcast. Have you ever wondered what it would be like to live in the ancient past, like 66 million years ago as the age of dinosaurs was ending, or 500 million years ago during the Cambrian explosion? Do you think you could survive? Could any human? For the team who produces the popular YouTube channel PBS Eons, we are big fans of Eons, this is a question they get asked all the time. Eons Surviving Deep Time is a podcast that explores this simple yet fascinating hypothetical. In each episode, host Callie Moore takes Michelle Barboza Ramirez, Blake DePestino, Gabriel Santos, and special guests on a time-traveling journey into Earth's history. Along the way, they'll discuss the conditions that they'll have to grapple with. We're talking apex predators, food sources, environmental hazards, and massive climactic events. Whether you're a fan of natural history or just a good what if, you'll enjoy Eons Surviving Deep Time, available wherever you get your podcasts. I feel very confident that our audience are fans of natural history and a good what if. That is very much in our wheelhouse.
Yeah, very on brand.
So go check out Eons. They do a great YouTube series and they do a great podcast.
Absolutely. And now we can wrap up the announcements and move on to the news. Thank you. Every episode, we like to go over some recent news in the world of paleontology, evolutionary biology, and earth sciences to help us all stay up to date with what's going on. This time, I'm gonna go first.
Well, fine.
'Cause I was told to.
You sure were.
My first news is about the fact that they have finally discovered what the head of Arthropleura looks like, the giant ancient millipede.
Yeah, I heard about this.
We evidently haven't found their heads up till now. Now we have an idea of what their heads look like, and it's weird.
Fantastic. That's the best part.
Yes.
We've been missing the best part.
Yes. This is research by Mikhail Leritier et al. In Science Advances, and the article is by Olatunji Osha Williams in Smithsonian Magazine.
That link will be in the blog post.
So, Arthropleura, very famous ancient arthropod. This was a giant millipede-like animal that lived during the Carboniferous, roughly between like 300 and not quite 50 and just a little bit less than 300 million years ago. It is one of the largest arthropods. In the paper, they called it the largest, which makes me wonder if the measurements with it, and I always forget the name of it.
There are some big Eurypterids.
Yeah.
I wonder if this is the largest terrestrial arthropod.
Either way, it's like neck in neck with a couple of other fossil arthropods.
Yeah, Arthropleura is huge.
The sizes they gave in the abstract for the paper is roughly 110 pounds and 9 feet long. Massive.
A 3-meter millipede.
It's one of those, that's a big animal anyway.
That's big for a snake.
Yeah, exactly. Like, that's a long length for like a gator. Mm-hmm. And that's heavy for any animal.
Yes.
That's a heavy animal, period. And we're talking about a millipede type thing.
This is a big millipede.
Very charismatic, very famous, but its fossils are typically incomplete. Usually the remnants of shed exoskeletons. Mm-hmm. Not the actual body fossil, but the outside of the body. And the face is missing, because I'm assuming that's where they came out of when they shed their skin.
That makes sense.
This has not only meant that we can't know for sure what its face looked like, therefore that informs how it eats, how it behaves, how it lives, but also who it's related to. Mm-hmm. It's been very unclear whether it should be on the millipede or centipede side of things.
Okay.
It's agreed that it's a myriapod, which is what includes those two, but whose side of the family it should sit at hasn't been clear. This study is on a couple of exceptionally preserved specimens. These are from France and are 2 juveniles. Very well preserved, less than 2 inches long.
Oh.
So
I was about to make a joke about like, juveniles, so they were only like 5 feet long.
Yeah, right?
But no, like little babies.
Little babies. Now, this might be a species that didn't get up to... Like,
sure.
Arthropleura is the genus. There are multiple species within this genus. This might be a smaller species.
Okay.
But does seem to be Arthropleura and very similar in other respects. Micro-CT scans allowed them to get fine details and were able to finally see what the face and mouth parts and head looked like. This is the first time we've got a glimpse of that, and it's weird.
That does not surprise me at all.
Absolutely.
Of course it's weird.
Roughly speaking, the head looks like circular in shape, with 2 antennae coming off, small mandibles underneath the head, and eye stalks.
Oh.
Yeah. The eyes are on stalks that protrude out to the side. The head's also interesting for the fact that it has features of both millipedes and centipedes.
Okay.
It has, at roughly speaking, the body of a millipede and a head more like a centipede.
Oh, interesting.
Yeah. Like millipedes, it has 2 pairs of legs on each section of the body. while centipedes have one pair of legs on each section, which makes them faster, more mobile. This likely means that Arthropleura was likely slower like today's millipedes are.
Millipedes are also, as far as I know, more typically herbivores,
Yes.
whereas centipedes tend to be predators.
And the features of the mouth do seem to support that it was also probably herbivorous, so not predatory.
Okay, interesting.
So it's probably slow-moving herbivore, which its body supports, and the face also seems to support that. Just for some fun numbers, Arthropleura had 24 body segments, which means 44 pairs of legs, which means 88 legs in total.
That's cool. Way less than I would have
Right?
guessed.
Not even a true centipede. It
No.
doesn't actually even have 100.
Didn't even make it.
Right? But yeah, there you go. The jaw position resembles a centipede. So where the jaws are on the face is more like the location you'd find them on a centipede than a millipede, but the shape of the jaws and the shape of the antennae are more similar to a millipede.
Okay.
So it's got a millipede-like-
The diet is likely similar
Yeah.
to a millipede.
It's got a millipede-shaped mouth, but placed where a centipede's would be. All this goes to show that it's probably herbivorous like millipedes are today. Also, it doesn't have any predatory features like the pincers of a centipede.
Sure.
So it doesn't have anything that shows how it would catch prey if it were carnivorous. The part that doesn't fit into either group are the eye stalks.
Yeah.
Not known from any centipedes or millipedes today or any other fossil ones that we know of. This is a feature unique among myriapods, it seems. They say they resemble the eye stalks of crabs. Like they're similar in anatomy, which could potentially point to maybe they had an aquatic phase when they were juveniles. Like maybe this is a juvenile feature. Maybe this is key to how they develop. But that is a curveball that we were not expecting and we do not fully understand yet.
Weird.
Yeah. This new data they used to combine into what they called a total evidenced phylogeny, using the physical characteristics and transcriptomatic data, which is RNA data.
From the modern species.
Yes. To get an idea of where Arthropleura should fit within the overall myriapod family group, and found that it fits closer to millipedes. And in one result, it is by itself as a stem member of millipedes toward the base. If another incomplete cousin of Arthropleura, Arthropleura, is included, it moves deeper into the myriapod stem lineage, so a little bit further it seems. But it does group closer to millipedes. So exactly how close and how far from the base of the millipede family tree it is still maybe up for debate, but it's more a millipede than a centipede.
That is extremely cool. That's extremely cool to know. I didn't know we didn't have heads
Right?
of Arthropleura. That was news to me. Also, delighted to hear that it is more like a millipede in both its relationships and its inferred lifestyle, because 9-foot millipede and 9-foot centipede are two very different prospects.
Those are very different genres of movie.
Yes, absolutely. 9-foot millipede is like a Pete's Friendly Dragon,
Yes.
kind of like, yeah, that's like your big Clifford the Big Red Dog,
Yeah.
a big fun friend. 9-foot centipede is a horror movie.
Yep.
I'm much happier with this.
Absolutely. They did make a point, which I found fun, that there's still things we are hoping to find and have not yet found. And one of the things they pointed out, which is just, I had never heard this angle and never thought of it, is if we could find a specimen that shows us the breathing system, that might help answer how it got so big.
Oh, yeah.
Because that's often thought of why arthropods were so much bigger back then, is oxygen levels were higher because of the way arthropods breathe. Higher oxygen could allow for bigger bodies, but we don't know what breathing system Arthropleura had, whether they had the passive breathing tubes that, like a lot of insects do, or like book lungs like an arachnid. So it's just, I like that they made a note of, we don't know Arthropleura yet.
Right.
There's still
more
big questions we don't know about this really weird animal, which I found that fun.
That is very cool. Hey, I've got some news. My first news is not about the heads of anything. It's about the opposite. It is about feet.
Oh, I was going to say butts.
Well, that's where it goes. Feet. And not from arthropods, but the opposite, birds.
All right.
Specifically, trends in evolution and lifestyle of Cretaceous birds inferred from some foot bones.
Cool.
This is research by Alexander Clark et al. In the journal PLOS ONE, and we will link in the blog post to an article on Cosmos by Evrim Yazgin. Birds were all over the place in the Cretaceous period. Contrary to sometimes popular belief, birds were around before the extinction of the dinosaurs, and in fact they were doing extremely well. In particular, enantiornithine birds were very widespread and abundant. This is an ancient group of birds that makes up more than half of known Cretaceous bird species. These were the main birds around at the time.
Yeah.
But our understanding of Cretaceous birds is incomplete in part because most of our knowledge of Cretaceous birds comes from the early Cretaceous.
Oh, interesting.
We don't have very much from the late Cretaceous, and what we do have is usually just bits and pieces.
Huh.
This means we're missing part of the picture of bird evolution. It also means we have less information about what birds were doing as we get closer to the end Cretaceous mass extinction.
Yeah.
Which would be nice to know. This study describes new bird fossils from the Hell Creek Formation. That is a famous formation here in North America, episode 127, which is the very end of the Cretaceous period. All three of these new birds are described from lower parts of the feet, the hind limbs, mainly the tarsometatarsus, which is a lower part of the foot bones on birds. These foot bones are not nearly complete specimens, but they are identifiable, and they give information about the lifestyle and overall features of these birds. All three of the new birds are enantiorniths, which is not surprising. Those were super common back then. One of them is a new genus and species, Magnus avis echolocaensis. The other two new species are both in the genus Avisaurus. One is here named Avisaurus darwini, and the other one, it sounds like, didn't get a new species name, but is not any other known species.
Yes.
So it hasn't actually been described as a new species, but it doesn't match anybody else. These discoveries are exciting for a few reasons. One, according to the authors, this doubles the number of known bird species from the Hell Creek Formation.
Oh, wow.
So that's cool.
Nice.
Increase the sample size. Also, all of these new birds are surprisingly large. Most enantiornithines from the early Cretaceous, according to the paper, are like sparrow-sized.
Yeah.
Or up to a little bigger, ranging typically between 10 grams or up to 200 grams. So, little tiny birds. The largest known is about 700 grams.
All right.
So, a little more than half a kilogram. A pound and a half of bird. This study, one of the new species, Avisaurus darwini, based on this foot bone, is estimated to be over a kilogram, 1,200 grams, which is about the size of a hawk.
Nice.
They also estimate another previously known related species at 1,700 grams, so going on 2 kilograms. So these are hawk-eagle-sized birds rather than little sparrow-sized birds.
Yeah.
And the final thing, and the thing that makes the headlines and such, is the proportions and the muscle attachments on the feet. So the proportions of the bones, but then also the projections on the bones where muscles would have attached. Specifically in the two Avisaurus species, the authors note, are similar to modern birds like hawks and owls.
Okay.
Where the bone and muscle proportions are an adaptation for a strong grip.
Yes.
That these modern birds use for grabbing and lifting prey.
Mm-hmm.
They do note that the overall anatomy of these birds, from what fossils we have, isn't identical to modern birds of prey, but the feet seem to be adapted for doing something very similar to modern birds of prey, which we don't see in other known enantiorniths.
Cool.
This is exciting. Again, more birds from the late Cretaceous, which we didn't have. Also gives us some insights into trends in the evolution of these birds that towards the later Cretaceous, at least some of them were getting larger, and by the late Cretaceous, there were effectively enantiornith versions of birds of prey.
Yeah.
There were raptorial Cretaceous birds.
Very cool. This is a fun discovery, and these kinds of discoveries are fun. Because I'd never given thought to whether or not there were predatory enantiorniths. But if you had asked me, I would have assumed there were because, many bird groups have come to that kind of hook-beaked, large-bodied bird of prey. There's water birds and, many groups that have done that. But getting to actually find them is very cool. And I had never even just thought to question whether or not. So the fact that they also seem to be a unique situation is very interesting. That this isn't a thing they were doing, it seems, everywhere all the time.
Yeah.
It seems like that this is a kind of a special situation, maybe. That's very intriguing. Cool.
Yeah, presumably there would have been a lot of little mammals and reptiles and tiny dinosaurs for them to, swoop down and pick up and fly away.
See, it's funny because I earlier when you were talking about the fact that we don't have a lot of fossils for them at the end Cretaceous right before the extinction, which is inconvenient. I was going to make a joke of like, yeah, it's like someone turned off the security cameras right before, makes it seem much more suspicious.
They so longed in thanks for all the fish out
right
before the asteroid came in, and then they came back.
Yes.
And they were like, all right, this is better now.
Yep. Now it's like, so were you guys the ones that turned the camera off? Were you the murder birds?
Did you send the asteroid?
That's awesome.
Very cool.
Very cool. My next news is also about dinosaurs, but non-avian dinosaurs, and specifically their eggs, some very small dinosaur eggs found in China. This is research by Rui Wu et al. In Historical Biology, and the article is by Gary Manners in ancientorigins.net. There are fossil sites in South and Southeast China, well known for dinosaur eggs, from the Upper Cretaceous. One of them in the Ganzhou Basin is among one of the richest fossil sites in the world for egg fossils. This research is reporting on a partial egg clutch, so multiple eggs and in varying degrees of completeness of the eggs preserved, with 6 complete small eggs dating to about 80 million years old. All in all, this is a well-preserved clutch. So that's high quality fossil for eggs, and is notable for being the smallest dinosaur eggs ever recorded. The previous record were I'm not sure how many there were, that were 45.5 millimeters long, or 1.79 inches. These are only 29 millimeters long, or 1.14 inches long.
That is an extremely small egg.
Teeny tiny.
Wow.
Yeah.
That's so small.
We're getting down to, like you were saying, this is getting songbird sized.
Yeah.
And yeah, these are tiny eggs. Analysis of the eggshell, using things like electron microscopes, we're able to determine that this is indeed a non-avian theropod egg. Features of the shell can give information like that, which makes it the smallest non-avian dinosaur egg. Like, there are bird eggs smaller than this, but for non-avian hummingbird eggs and stuff are like
that makes
the
sense.
Size of marbles.
Sure.
This is like a good gumball.
Yeah.
This is like a good gumball-sized egg. These were identified based on various features to be assigned to the Oo genus, which is like for trace fossils we give ichnotaxa. There are also taxa for eggs, since we can't always match it to the animal it went to, of Ovulo-Olithidae, but was also able to be identified as a new Oo genus due to the small size, the irregular egg arrangement in the clutch, which is a feature I hadn't thought about being a thing you would identify, but the way the eggs were laid, it seems. Worm-like and nodular ornamentation, so the texturing and the patterning, it seems, on the egg. And the gradual boundary between the structural layers, so the way the layers of the eggshell meet up, all came together to put it in a new Oo genus of Minioolithus ganjoensis. So this is a new taxa of fossil eggs. They don't yet know what dinosaur these go to, though they are, at the end of the article, they noted that they are determined to find out. Like,
start cracking open some of those eggs.
That is their next main goal. This is very exciting because record breakers are always interesting. They expand the range that we are now aware of that non-avian theropod, two-legged predatory dinosaurs could get to.
Yeah, it also suggests very tiny dinosaurs.
Yes, exactly. So this increases the diversity of dinosaur eggs known from the late Cretaceous, Also gives info about what kind of dinosaurs might be in that habitat if we have not yet found dinosaurs of that size or something. It'll also probably be very significant for understanding the evolution of late Cretaceous theropods in that area of the world. The next step they want to do is use micro CT scanning to reconstruct the nest and learn more about how the eggs were laid and preserved and see if that tells them anything about what dinosaur or any info about the dinosaur that would have laid them. So yeah, teeny tiny non-bird dinosaur eggs.
I assume, because this is a nest that's preserved within sediment, that this is a ground nest, and I don't think we have any direct evidence of fossil dinosaurs making nests elsewhere, like in trees and stuff. I don't know anything about birds, so I don't know if we have a size limit in modern birds for ground nesters.
Yep.
I tend to think of ground nesting birds today as being bigger,
Mm-hmm.
so I don't know. I wonder what effect that has if your eggs are super tiny, but you also are laying your eggs in a nest on the ground.
It also makes me wonder if that would tell us anything about the environment. Or are ground nesting birds more common in certain ecosystems? I do know there are some small ground nesters. I can't remember the name of the bird right now, so please let me know if you recognize.
People who know birds, let us know what we're wrong about.
There's one famous one that is a ground nester, and they are notable for the parent will act injured and move away from the nest to try to draw predators and animals that get too close to the nest.
Yes,
they
I know
were
what bird you're talking
on
about.
a construction site my dad worked at one time, and he showed me them. But yeah, that bird is robin sized, a little bit smaller than a pigeon. So that's not a very big bird, and they are ground nesters strictly, I'm pretty sure.
Interesting. This does suggest that there are extremely tiny theropod dinosaurs out there for us to find.
Right.
Which is great.
It's and just darting around. So cool.
Well, I've got one last bit of news, and this is an interesting news that is not about fossils or indeed about animals at all. It is about education and the long-term effects of science education here in the U.S. This one's really cool. This is research by Benjamin Arnold in the Quarterly Journal of Economics, and we will link to, it's actually a blog post by the author on the London School of Economics and Political Science website that goes over a review of this paper. The paper is also open access, so you can all check it out.
Nice.
This paper specifically investigates the teaching of evolution in United States high schools. For anybody out there who maybe isn't from the U.S., teaching of evolution here in the U.S. has been highly controversial for a long time.
Yep.
Over the decades, there have been various changes to the educational systems in different states in our country that have impacted how a variety of topics are taught in sciences. Evolution is one of the most famous ones that has sort of gotten shifted back and forth. This paper examines how these changes in science education, focusing on evolution curriculum, affect students later on.
Yeah.
Specifically looking at three categories: their knowledge of evolution, their reported belief in evolution, and later career choices as they grow up.
Okay.
This study looks at, so the time range for this study is 2000 to 2009, so the first decade of the century. During this time, various U.S. states made changes that either increased or decreased how much evolution was covered in schools. This paper started by looking at the curriculum and giving it a score based on how comprehensive the evolution coverage was, identifying that 22 states increased their comprehensiveness and 15 decreased over that time period. Then they went and found data for the people who were high school students during those times to see how those changes might have affected other factors. Their first result, somewhat unsurprisingly, is that better evolution coverage in schools led to better understanding of evolution.
Makes sense.
They got this data from standardized tests, so these are nationwide standardized tests that include some biology questions, some questions directly about evolution, and they found that students who had a curriculum with higher comprehensive evolution education got more evolution-related questions correct on the test. That one's pretty simple and straightforward, but hey, it's nice to know that education works.
Yes, yeah, good job, teachers who taught those students.
Part 2, they found that more comprehensive coverage is linked to more reported belief in evolution. This, they got data from the General Social Survey, which is done over time, and part of the survey is birth year, so they were able to say, okay, these people would have been in high school during this time of these coverages. These kinds of surveys ask people about all sorts, political views and religious views, and often they include things like your perspective on climate change or evolution, things like that.
Just getting a general read on how you see things.
Here in the U.S., it is not at all uncommon for people to report not believing in evolution or partial belief or uncertainty, things like that.
Yeah, there are regions where that is the norm among people.
This study found that comparing the higher evolution coverage to lower evolution coverage in different states at different times, better coverage led to more reported belief in evolution. In fact, they noted that comprehensive coverage compared to no coverage in the curriculum saw an increase by 57% of the average in number of people reporting confidence and belief in the science of evolution. Yet more interesting, they found that the degree of evolution in the education had no detectable effect on religious views, political views, or other science-related perspectives.
Yeah.
That part is very interesting.
Very intriguing.
Because there is a bit of sort of common thought knowledge, and there have even been some studies that have potentially supported this, that certain topics like evolution and other science knowledge competes with religious or political beliefs, that higher belief in one negates belief in the other one.
Yeah, there's a very common just assumption that if I know your feelings on evolution, I might be able to guess a few other things about you.
Right. And obviously there are correlations with political views and religious views and scientific views, but the data in this study suggest that teaching of evolution in school curriculum does not seem to have an effect on religious or political views. And they do point out in the paper that this is the latest in a series of studies that have been showing this.
Yeah.
Which is very interesting. That is a very interesting and surprising somewhat result.
Yes.
The third part is that they found also that better evolution education in schools is linked to more students going into biological careers later on. They looked at data from community surveys that include people's occupations and found that in states at times with better evolution education, more students went on to work in life sciences fields, specifically in biological, like biology type fields.
Cool.
And that's good to know because that reinforces the idea that good science education can attract people to science careers.
Well, and can make those careers look accessible and like an option.
Yeah, and that's a really big one because a lot of institutions, organizations, political institutions, but also just academic institutions are very interested in how do we get more people into science and technology fields.
Yes.
And this data suggests that one of the ways you do it is by improving science education, making more comprehensive science education at the at least high school and perhaps elsewhere level. This is, obviously the focus of this paper is specifically on evolution, but the author points out that this has much broader implications.
Yes.
For how early education, right, how high school education in this case, can affect students, and then as they become adults, not only understanding and viewpoints and acceptance of scientific topics, but also their likelihood to then get involved and engaged in those kinds of sciences as adults.
Yes.
They even make the point in the paper that evolution is an interesting case because evolution is also extremely controversial in many circles.
Yep.
So they note, somewhere toward the end of the article, they make a note that the effects might even be greater for other scientific topics
that don't have
that don't have that sort of social stigma around them. But this has implications for education about, climate science, medical science, stuff like agriculture, right, where it's very important for people to understand and trust scientific information. This is it's a very relatively narrow case study. And I also appreciate that it is getting data from the indecisiveness of our various institutions' educational approach.
Yep.
It's like, yes, while all these states keep going back and forth, let's get some data of what the effects of that are.
Well, and it's a nice reminder on that note of, like, we all know that education is investment in the future of those individuals and how they will impact our society. Like, that children are our future is a phrase for a reason, and it's a phrase because it is literal, and education is how you impart things onto that future. But it's often left kind of vague with just what I said being
right.
The
total. There's not a lot of numbers.
Exactly. Like, so what? But what does that mean? Like, how much of what I do is gonna affect how much of having some numbers and having some. It reinforces of, like, yeah, giving them good education makes a big difference. Like, the education you decide to do will have resounding effects for decades.
Well, and this pairs very nicely with all of, people who have anecdotal stories of, I had a math teacher when I was in 9th grade who I just didn't like, or I thought they were terrible, and so I hated math for the rest of my life.
Yeah, exactly. Ruined blank topic for me.
Or the opposite, right?
Yes.
I didn't like chemistry, and then I took chemistry, and I had this amazing chemistry teacher, and that inspired me to go on and become a chemist. We know anecdotally that our experiences in education and the kind of education we get can affect our minor and major life decisions later on. This is a nice way to show, here are the percentages.
Yes.
Here's what percentage of students are impacted in that way.
Yeah.
Which is very cool.
Very, very interesting. I would love to see this kind of study done just on every topic.
Sure.
Just because that's a fascinating kind of study.
And this is by far not the first study of its kind. There's tons of references in this paper to other similar studies.
Well, and it's a thing you have to do again, and
yes,
we can't now be like, all right, we figured out how it works with that. No, you have to do it with the next generation too, and then the one after that, and then the one, like, for forever we can be doing these studies. But it's awesome, and it's important for us now to be able to make decisions off of this data.
Yes. So, on a completely unrelated note, everybody go vote.
Yes.
Hey, speaking of science education,
let's talk about rodents and learn about them. After a brief musical interlude, we will jump into what it means to be a rodent, what makes a rodent, and how many of them there are.
Squeak, squeaker.
Squeak, squeaking. I'm excited to finally get to talk about rodents in a bit more focused detail, since we often reference them as the default mammal.
It's hard not to talk about rodents in passing because they are ubiquitous.
Yes. Like, we just got done talking about the intimidatingly massive topic of fungi. Rodents is also an intimidatingly massive topic. We are going to be just focusing on rodentia, the group that includes all rodents today. We're not going to be diving into a lot of the specific groups. So if we...
This is the intro.
Yeah, if we skip one, don't feel like it's getting spurned.
Submit your requests now for whatever specific group of rodents you want us to do an episode about.
Rodents are the most diverse group of mammals on the planet. As definitely, for sure, non-flying mammals.
Yes.
Bats are pretty close, but rodents, from the numbers I've seen, are still even more diverse than bats.
Yeah. And even if not in sheer number of, like, distinct species, the diversity of lifestyle and body shape, rodents are preposterously diverse and successful.
They are diverse in form, many in species, Currently, as of 2021, the American Society of Mammalogists recognizes 481 genera of rodent, including 2,277 species.
Yes, which is almost half of living mammal species.
Yeah, the percentage I saw was 40%.
Yep.
Rodents alone make up almost half of mammals.
Yeah, if you throw a rock and hit a mammal, odds are it's a rodent.
Yep.
Especially if you're on land.
It's insane. It's like we often talk about how if you ask an alien, what the dominant life form on Earth, they'd very likely say plants.
Yep.
And if you ask, okay, but animal-wise, rodent would not be a bad answer.
Yeah, in much the same way that, there are reptiles, but most reptiles are lizards.
Yes.
And most of the ones that aren't lizards are things that look a lot like lizards.
Yes.
Most mammals are either rodents or things that look a lot like rodents, or bats, which also look a lot like rodents.
Yep. They're everywhere. As the classic phrase goes, every continent but Antarctica.
Yes.
They're also the only terrestrial placental mammals to have colonized Australia and New Guinea without our help.
Oh, yeah. They got there even before
Yes.
we could carry them over there.
Not including bats flying over, but
Sure.
walking mammals. They're the only ones who got there without us using ships. They are super abundant, crazy diverse. There are animals that are rodents that some of you might be surprised during this episode to find out are rodents.
Yep. There's also probably animals that aren't rodents that
Yes.
you would be surprised to find out aren't rodents.
But they do have shared features that makes them a group.
Yes, Rodentia is an order.
It is.
Rodents are a taxonomic group.
They are all grouped together, and they have some actually very strongly connected features. They are surprisingly consistent in a few ways. The big one, and what defines this group, is their teeth, specifically that they have 2 front teeth on the top and bottom of their mouth. They're incisors. They have a pair of incisors on the top jaw, pair of incisors on the lower jaw, and they are ever growing.
Yes.
So these are the famous buck teeth of mice and hamsters and gerbils and anyone who's had a pet rodent, those teeth that stick out of the mouth. These are those incisors. They're ever growing. They have a special anatomy. That means they are tougher on the front. They have enamel on the front, which is very hard, and dentine in the back, which means when they wear down in that chisel shape.
Yeah, if you look at a rodent incisor from the side, it tapers to a point at the business end, at the
Yes.
chewing surface, and as they chew, they sharpen it into that shape effectively.
And because they're ever growing, they don't ever wear it down.
Yes, which is why they have to keep
Yes.
chewing, because otherwise those teeth will grow out of control.
As one paper put it, so they do not pierce the skull.
Yes, that'll happen.
They will just grow, their teeth can just keep growing into the mouth.
If you look at the skull of a rodent, they look very distinctive.
Yes.
They've got this, usually it's kind of a flat top, this long-ish face, and then these just 2 pairs of teeth that form this arc in the front of the mouth. There are lots of animals that have rodent-like skulls.
Yes.
So that it isn't always a rodent, but they have this very distinctive look, in part because of the shape of those incisors.
Absolutely. And moving back from those, the next most obvious thing that most people will probably notice is there's a very large gap between those front teeth and the next teeth.
Yes, a very big diastema.
A diastema. They have this portion of the jaws that are toothless before you get to the molars and 1 or 2 premolars. They have no canines and have lost their front premolars. So it's mostly just 2 incisors and a bunch of molars.
The chisel and the grinders.
Yep. And this is the characteristic rodent tooth arrangement, which is how a lot of mammals are grouped. This is consistent and diagnostic. We use this to identify rodents.
Interestingly enough, one of the groups already in this episode that we have been comparing a lot with rodents, bats, do not have skulls that look like that. Bat skulls look radically different from rodent skulls.
And you will see other animals that have large diastemas, like horses and a lot of your herbivorous animals like that. But they have many front teeth, or at least on one part of the jaw usually.
Right. And they don't have the same incisor anatomy.
Yep.
They don't have those big, long front teeth. Koalas do.
Yeah.
Koala skulls look a lot like rodent skulls.
There's a
Not
number
rodents.
of marsupials that have very rodent-esque mouths.
Yep, because rodent is one of the best ways to be mammal.
Yep.
So lots of things that aren't rodents have become very rodent-like.
This gap between the teeth actually does a number of cool things for rodents. One is it allows them to use their front teeth as tools in ways we don't usually see teeth used. They can suck in their cheeks behind their incisors, many of them can at least, and chew with the incisors out of the mouth while the lips seal the rest of the mouth.
Mm-hmm.
This allows beavers to chew on wood without just swallowing tons of wood chips that most of that wood they wouldn't eat anyway. It allows for them to chew underwater. It allows for naked mole rats to dig without swallowing a bunch of dirt. So they can use that gap to seal the front and the back of the mouth and separate them when they're working.
Very strange thing to do.
It also allows many rodents to have their cheek pouches.
Yep.
Famously in like hamsters and stuff. Kangaroo rats, chipmunks are famous for this. Mm-hmm. They have elastic skin on either side of the face and mouth. This pouch can extend down to the shoulders in some rodents. And they can store food in there and then take it back to their nest where they can eat. Not all rodents have this. Mice and rats do not have cheek pouches. Mm-hmm. They have stretchier cheeks because of the musculature and fibers there, but not true pouches. Their molars are often big and long, like a horse's, where they are going to wear those down over their life because they are often chewing on tougher food for many of them. There are some, the chinchillas and guinea pigs, have such a high fiber diet that they do actually have open-rooted molars.
Oh, interesting.
Yep.
So ever-growing molars, essentially.
I think I had heard that back in the past, and I thought it was all rodents.
Yeah.
But it is these rodents. So some rodents also have ever-growing back teeth. The most distinctive thing, though, about the gap between these two sets of teeth and the difference between these two sets of teeth is that they allow for two different forms of chewing and biting. Rodents have two distinct modes of using their teeth. Gnawing with the front teeth, with those incisors. This is that chiseling, that I'm working my way through a piece of food.
When you see a cartoon beaver or chipmunk or something chisel away at a piece of wood, that's gnawing with those incisors.
Yes. And then they chew with the back teeth, which is what you think of as chewing. What we do when we chew.
Sure. Crushing and grinding up the food.
We're sliding the teeth back and forth against each other in some pattern to smush food. These cannot be done simultaneously.
That makes sense.
Yeah. The angle of the teeth and the proportions of the two jaws mean that they cannot gnaw and chew at the same time, and they can't chew and gnaw at the same time. But it means they can be more specialized in each, so they can shift the jaw into gear, basically.
Yeah.
They shift the lower jaw forward to gnaw and back to chew.
Yeah, I assume that they have to adjust how much of an underbite they have.
Yes.
With those incisors.
Yeah, like when they're chewing, the lower incisors are not meeting up with the upper incisors.
Yeah.
And then they have to bring them forward to form that chisel, but that means that the back teeth are no longer occluding.
Yes.
This
That's
is
cool. It's cool to have jaws with different modes.
Right?
Different settings.
Yeah, to gears,
Yeah.
like on a bike. This is known as diprotodonty and is famous in some other groups like
Diprotodon.
Diprotodon.
Which is a marsupial.
Yep, there are marsupials that have also evolved this. Eyes have a similar dentition.
Oh, cool.
And multituberculates, a fossil group, which we'll talk more about later. So this is not unique to rodents, but they are by far the most famous for this feature. So that's how we define a rodent. Where rodents are among mammals is in a clade called glires. This is a clade in relation to primates and tree shrews, so it's in that area of mammals. And it includes rodents and logomorphs, which are your rabbits, your hares, your pikas.
Yes. Very close to rodents, not actually rodents.
Yeah, they are a sister group.
And this is something you'll see a lot in science communication or in technical papers because rabbits are often studied by the same people who study rodents, and they'll often be included in the same studies. So you will constantly see this qualification of rodents and rabbits.
Well, and it's
all the rodents and rabbits.
Yep, and it's one of those where if at a glance, given the description of rodents we just gave you, I would not blame you to look at a rabbit and go, well, rodent.
Yep.
And they are very similar. They have ever-growing incisors that are chisel-shaped. They have a gap between the back teeth very often. But logomorphs have 2 incisors in the bottom jaw, just like rodents, but 4 on the top jaw.
Yeah, we got that extra pair up top.
Yeah, they have 2 pairs. Now, the second pair in many of them are minuscule.
Yeah, easy to miss.
So, like, if I pulled them out of a skull before giving it to you, you might not notice that gap was a missing tooth.
Yes.
They are very tiny, but they are, that is a consistent distinction between these 2 groups.
Yes. Lagomorphs, also extremely fascinating, highly diverse and successful. Not this episode.
Yeah.
You'll have to wait for their own episode.
It's fun because they, the clade of Glyers I saw described as the gnawing mammals.
Oh, fun.
This is a group that collects, one paper said, buck-toothed gnawing mammals.
Yes.
Which is really what unites them, but they are doing it slightly differently.
And then outside of that group is where we find primates and some of those other rodent-like creatures.
Tree shrews, gliding lemurs and stuff. Like,
yeah,
it's an odd grouping. Like, it's
an odd grouping, but you can see it.
I can see it.
You're like, okay, yeah, rodents and primates. I can see it.
Oh,
you can see that connection.
That's where the troublemakers are.
You know who's not in that group? Bats.
Bats
off doing their own thing.
Okay.
Episode 59. Go learn where bats are on the mammal family tree because I honestly don't remember.
Now, rodent classification, as we zoom into Rodentia, has shifted a lot over time, and the way we group them has changed. Part of this is that rodent evolution can make them difficult to categorize because they are the famous example of R strategists. R strategists is what we term animals that have lots of babies, fast generations, and fast lifespan, short lifespans, and typically not a lot of heavy-duty parental care.
Right. It's quantity over quality.
Exactly.
Outside of rodents, the classic example of this is a lot of insects.
Insects are your typical go-to.
Or fish.
Yes.
Fish often do this, where it's like, I'm going to have 1 million babies, and I'm just going to send them out into the world, and by the law of large numbers, we will survive.
Yes.
Rodents are excellent at doing that. That's one of the things they're famous for. It's partially why rodents make such good scientific subjects.
Absolutely.
And it's partially why they make such good house pests.
Yes.
Because, if you've got a couple of rats, it's not very long before you've got a couple of 100 rats.
Because even with all the city funding you could want, you would have a difficult time keeping up with the rate that mice and rats can reproduce.
Yes.
This is paired with the fact that many rodents also have very high rates of mutation. Another famous thing that makes them tough pests. They can become immune to poisons in a number of generations that is surprisingly short. But this can lead to a phenomena known as long branch attraction, where you can get lineages of rodents that have evolved really fast and have created these really long evolutionary branches on the tree, which means the next most closely related rodent, at a glance, looks really distantly related, but is just the branch over. Yeah. And so it means that, like, mice can go off on these long evolutionary fast tracks, and then things like the guinea pig, which are a little more conserved, not quite as fast evolving, can at a glance look like they're actually closer to primates when you do the analysis. So you can get these branches that seem to suggest more distant relations or more close relations within the branch. So it's made things tricky. One way that rodents got grouped was based on their jaw musculature. Their jaws are very highly specialized, not just in the teeth, but the muscles are very unique among rodents. The masseter is the dominant jaw closing muscle, and in rodents, it makes up 60 to 80% of the jaw musculature. Just this one muscle.
You're doing a lot of chewing.
And it's divided into 3 layers: the superficial, the deep, and the zygomatical mandibularis, or medial. And rodents have adapted this masseter muscle by moving it further down the snout to give stronger bites and more torque on their chewing ability. One of the side effects of moving the masseter further down the snout is that it is what contributes to the eye bulging that happens in rodents when they chew.
Oh.
And that's a famous thing with like rats and stuff, that when they bite down, their eyes bug out a little bit because the masseter...
the muscle's way up there?
Yeah, it connects in and sometimes through the orbit, and so it pushes on the eyeball.
Weird.
Now, rodents have moved it down by adapting different parts, different layers of the masseter, and this has grouped them into clades, and is one of the ways we used to distinguish groups of rodents, by these musculature. It was then found out that these are convergent.
So they're not clades.
So they're not actually true clades.
These aren't actual groups.
The names stuck around.
Okay.
And the terms will often still be used for the musculature, but often it's specified when they use it that way.
Right.
But you'll hear the same names even though the members have shifted to a more taxonomically accurate assemblage.
This will often happen with animal and plant and other thing groups, that they will originally get classified by some anatomical feature, and then later that gets split up, but that original name for the anatomy continues to get used, even though now it applies to several different groups that are unrelated to each other. If I had an example off the top of my head, I would say one. I tried to think of one and I couldn't think of one.
Well, and that's why these terms all have morph in the name.
Yes.
This is morphologies that fall in this category.
Yes.
But they aren't actually all closely related. The three groups are the Sauromorphy, Hystricomorphy, and Myomorphy.
I bet I know who's in some of those groups.
Yep. Yeah. Some of these stick around, and they do still typically mean who they are now famous for meaning.
Yes. Well, a Saurus is squirrels.
Yes.
So I assume Sauromorph essentially means they have the muscle shape that squirrels have.
Precisely.
Myo is mice. They have the
Yes.
muscle shape that we see in mice.
Exactly. Sauromorphs have squirrels, beavers, and pocket gophers.
Okay.
All have similar musculature.
Which emphasizes that point that these are disparate
Yes.
groups of rodents.
Very different. They've expanded the deep masseter, and it attaches under the widened portion of the zygomatic arch, which is the arch that runs under many animal eyes.
Yeah, the cheekbone.
The cheekbone. Ours doesn't stick out like others, but a lot of others, it's this arch of bone. This improves gnawing efficiency, which makes sense for chiseling wood and cracking open nuts. The hystricomorphs encompasses a lot of South American rodents, but also things like some old world forms like porcupines, jerboas, spring hares. They've extended the medial masseter up through the orbit, and it improves chewing efficiency.
Okay.
So a lot of these are, and like if you think of capybaras, which are famous South American and they're not actually grazers on grass, but they're browsers. So chewing on vegetation. And then myomorphs, mice, rats, and their relatives plus dormice. So this one actually is a lot of really closely related members. They've combined those two others, expanding the deep and medial masseters, and maximize both gnawing and chewing. Very versatile feeders. Mm-hmm. So they are kind of the jacks of all trades when it comes to the jaw musculature. These three groups were the original suborders of Rodentia. Then it was realized, actually, this has evolved multiple times across rodents. These features don't actually consistently show you who evolved from the same ancestor. It is now, at least in the current, when this episode's being recorded, a 5 suborder system for rodents. The suborder Sauromorph includes Sauridae, which is squirrels, and the mountain beaver, which isn't actually a beaver.
Sure isn't.
Yep. But it is a North American rodent that it's a ground squirrel, really, but it is its own group. Yeah. And it is the only surviving member of Aplodontiidae.
Super weird.
Yeah.
Very distinct. I remember Aplodontia mountain beavers because our professors in grad school used to wheel out mountain beaver skulls to trick us.
Yes.
Because they're very strange.
Yeah. They are often considered the most ancestral, at least in their shape, to what early rodents probably were like. Not exact, of course, but they have the most ancestral features still. So they stand out as different. This also includes, in Sauridae, you have squirrels, chipmunks, ground squirrels, flying squirrels. All of the true squirrels are in this group. They're found in the Americas, Eurasia, Africa. They were introduced to Australia. This also includes the dormice, which aren't actually mice. They're in here with the squirrels, found across Africa, Asia, and Europe.
That's going to be a recurring trend. There's a lot of things called rat and mice that are not rats or mice.
Evidently, their name comes from dormancy, because they have long dormant periods of up to like 6 months. Dormice is dormancy, not as in a door.
Huh.
Yeah, that's why it only has one O, I guess.
Well, there you go.
Yeah. They said that, I went, oh!
That makes all the sense.
That makes so much more sense. I just always assumed they somehow were related to, they have little doors on their mouse holes. The suborder Anomaluromorpha has sometimes been shifted from being a suborder to an infraorder, so like exactly where it is. So this one might shift
between our recording and when this episode
yeah,
releases.
Exactly. Like, this one could shift in the next study that comes out. This includes most of the rodents with the hystricomorphous jaw structure, specifically the ones in sub-Saharan Africa. This includes things like spring hares, scaly-tailed flying squirrels, flying mice, Cameroon scaly tail. The two families within this group might not actually be very closely related, so they may actually, like, there's been suggestions that they might actually should be in separate suborders. So this could get split based on some of the suggestions I saw mentioned. Suborder Castromorpha is ya beavers.
Mm-hmm.
These are in the Americas. They include beavers, also pocket gophers, and kangaroo rats and mice. Which, man, you're all over the place with that one.
They're just doing all sorts of weird things.
Then you have the suborder Hystricomorpha, which has the rest of your hystricomorph rodents, but not just in Africa. One group, the Phyomorpha, are found basically all in Africa except the old world porcupines, which are in also Europe and India, all the way into Southeast Asia. And then Cavimorpha, which are your new world hystricomorphs, and these are guinea pigs, capybara, and the huge selection of other South American rodents, which we will talk about at length throughout the episode. And then finally, last and most, the suborder Myomorpha. These are your mouse-like rodents, mice, rats, gerbils, hamsters, lemmings, voles. This contains 1,524 species based on one of the more recent papers I found.
So like a sixth, like 20% of mammals.
Yes, like rodents make up not quite half, like definitely a solid third of mammals. Mice alone make up almost a fourth.
Yep.
Just this group.
Mice, that's a good way to be a mammal.
In here you have two superfamilies, the Muroidea. The Muroidea, which are your mice and rats and voles. These are the mice, this is the mouse group.
True mice.
Yeah. True mice, and also includes true hamsters, true rat, like this has all of those.
Yep, floor mice.
Then you also have the superfamily Dipodoidea, which is other mouse things, but not the true mice. Your jerboas, birch mice, jumping mice, things like that. These are mostly found in the northern hemisphere in dry habitats. The Muroidea are found everywhere. Everywhere, especially anywhere we've been.
Yep, pretty much anywhere we live, there are rats and mice.
Where we go, they go.
They sure do.
The superfamily Dipodoidea is famous for all of them are hoppers. All of them have the ability to hop.
That's why I know that name from episode 193.
That is the classification of rodents. They include some of the most disparate examples of related mammals that you can find on Earth today. Arguably, they are one of the most diverse groups of land animals in the fact of amount of shapes and forms and habitats and lifestyles they fill. They're found on all the continents, as we've mentioned, as well as a bunch of islands and stuff. They also are in basically any habitat from tundra to desert, arboreal.
To city.
Yep. Cities, rainforests. There are semi-aquatic members. This success has been attributed to a number of their physical specializations. Their teeth, they're very efficient chewers and biters and gnawers. That means they can eat a variety of things very easily. They also are quite physically capable. Mm-hmm. Like, they don't look like a very athletic animal at a glance. They have fairly short limbs for their body size, a kind of roundish body, but they are actually quite mobile. Many of them can move quite quickly. Many of them are good climbers.
Yeah, a lot of them are very flexible.
Very flexible. Most can swim. Like most of your rodents that aren't swimmers actually are quite efficient once in the water.
A lot of them are also at least moderately good diggers.
Yes.
Like they tend to be good at burrowing and digging, either by digging with their claws or by chewing their way through stuff.
Exactly.
Like a rat can chew its way into the wall to find a new place to be.
They're also literally dexterous. Like they have basically what, if I were to ask you to, what I would define as hands.
Yeah. Well, very much like a raccoon.
Yes.
Where like a raccoon doesn't have hands quite the way that we have hands, but a raccoon can plop down on its butt and hold and manipulate things in its hands. Yeah. Rodents are also really good at that. That's where you get adorable videos online of like squirrels or gerbils or whatever holding food up to their mouth and then chewing on it.
And they are even more hand-like than raccoons are, to my knowledge. I haven't compared it to raccoons, so if I'm wrong, let me know. But like their first digit, which is our thumb, is actually quite thumb-like.
Yeah, there's that connection to primates
right?
we're talking about.
I saw a number of things refer to it as opposable.
Yeah, I've seen raccoons described that way too.
Yeah.
That this is we like to think of our hands as being highly unique among animals, and they're not quite that unique. There are a number of other mammals that have evolved similar opposable digits.
Yeah. Their thumb's not long like ours, so they probably can't do the touch your fingertips the same way.
Yeah.
Like, which is what I think of as how I explain when someone's like, what do you mean when you say opposable? I'm like, well, we can move our thumb all over the hand in a way that other animals can't. Theirs isn't quite that same. It's much shorter, but it is very mobile and it's off to the side. Mm-hmm. And they use it in holding things, either when they're holding it with both hands or for very small things, they just hold it between the thumb.
Yeah.
For like really little things are just held by the thumbs. They also have very flexible elbows, which gives them that forearm mobility.
Yeah. Well, it allows them to hold something up in front of their face.
Yes.
Like the way that a dog can't, but a cat can.
Yes, exactly.
That mobility of the arms.
While we're talking about their hands and feet, they are plantigrade for the most part.
That's true, they are. That means the heel slash
back
wrist,
of the palm.
the back of the palm, are on the ground when they're walking.
They flat-footed like us.
Like us.
There are some that aren't. The agouti is a more fleet-footed, and I saw it described as antelope-like.
Okay.
And they are digitigrade, so they're standing up on the fingers and toes, and
like
have
dogs and cats.
Yes, and have more hoof-like nails, while most rodents have more claw-like nails. There's also a whole bunch of cool specializations for living in different areas. There are semi-aquatic rodents, famously beavers, but there are other members. Muskrats are one of my favorite examples because they also have a flat tail, but unlike a beaver's, which is flat, like sitting against the ground, muskrat tails are laterally compressed, like an eel's tail. And so they have like a little rodent croc tail, this flattened, narrow tail, that does seem to produce a little bit of propulsive power by going back and forth like a fish.
Weird.
Yeah, which is one of the only mammals I can think of that swings its tail back and forth to swim.
That's a fish mouse.
Yeah, not much. It was like 1.4% propulsion.
Sure.
But it also is important for them not tipping over. Now, the study that found that was a very old study that found it out by amputating them. But they did find that without the tail, they tipped over a lot more. So it is a important rudder.
All right.
It's a good fact to know. I'm sorry for how we found it out.
Don't chop off muskrat tails.
Nope. There's also earless water rats from New Guinea. There's also a similar group in Australia that I saw described multiple times as the most aquatic rodent. I didn't find a lot of good info about them because, like, when you look them up, 2 pictures come up and no videos. So I couldn't get a lot of details.
Send in your requests now for an episode about whatever that group is.
Right. They have big, long back feet that are webbed. They have very small ears and eyes, which is where the name earless comes in. Their long tail has a row of hairs that run along the underside and act kind of like a rudder.
Yeah, like a fin of hair.
Yeah.
Weird.
As you mentioned, they have a lot of ways of getting around. There's burrowers, there's climbers, there's gliders.
Yeah, there's a bunch.
That came up in our gliding episode.
Yep, that was 148.
In many of these different locomotions, you'll see specializations in the tail because most rodents have fairly long tails. There are short-tailed rodents, guinea pigs and hamsters and capybaras and stuff like that have very short to effectively non-existent tails. But many have long tails, and you'll see them furry to hairless, prehensile, powerful, like there's muscular tails. I also found one mentioning that some of them use them for communication, giving the example of like beavers slapping the water.
Yep.
Evidently, house mice rattle their tails to indicate an alarm.
Interesting.
Yeah, I hadn't heard of that one before.
Like snakes?
Yeah!
That's super cool.
Isn't that great?
My sincerest apologies to all of the mice listening who heard me say the word snake.
It's-
There's no snakes around, I'm
yeah,
so sorry.
yeah, right?
That's probably not true.
How dare you compare us to them?
There's probably snakes around. Watch out.
I am nothing like that.
You'd better be R selected.
Speaking of eaten, rodents also have wide diversity of diets, though most are herbivorous.
Yes.
That's
pretty classic with rodents is that they tend to be plant eaters.
That is the default. There are many omnivorous, and even many of the classically herbivorous members will take some insects or small animals if they get the chance, like many herbivores will.
Yes.
As far as plant matter that they're eating goes, it includes basically any part of a plant that you can think of, famously seeds and fruits and stuff, but there are rodents that eat stems and leaves, there are flower-eating rodents, there are root-eating rodents, beavers eat wood, like there are basically any part of a plant, and probably any plant that you can point at, there's probably a rodent chewing on it and gnawing on it. Some of my favorite examples I found was plains pocket gophers are burrowing. Gophers are famously burrowing. And mostly eat material they find underground, so like tubers and roots. But the Texas pocket gopher does the Looney Tunes cartoon thing of, to avoid coming up to forage, they grab the roots of a plant and pull it down into the burrow. Like, there's full on the gophers from Looney Tunes.
That's awesome.
That's a real thing that happens. I also like the example I found of the African pouched rats, which have big cheek pouches. They go foraging up on the surface and basically just grab a bunch of stuff, shove it in their cheeks, go back to their den, and then sort out what's edible there.
Yep.
Which I love that it's just like, nope, toothpick, paperclip, ooh, Twinkie.
Yes.
Like, it's just like if you ran through the grocery store, shoved everything in your grocery basket,
Yeah,
drove home as fast as you could, and went, all right,
it's like
what are we having for dinner?
One of those sweepstakes
Yes.
that they used to do. It's like, yeah, you've got 10 minutes to grab but as much as will fit in your cart.
Yes. As mentioned, many of these will still take insects or other food. Like rats and mice are often mostly herbivorous, but everyone's seen a video or two of a New York City rat like taking down a pigeon or something.
Oh, sure.
Or a
Well,
piece of pizza.
And rats and mice are also famous for the fact that when they start to run out of food, they will start to eat each other.
Yes, absolutely. There are some carnivorous rodents. Not a big list, but there are some that I saw noted as more carnivorous than not. Some even called obligate carnivores, that they basically are only meat eaters.
Already, this is weird, specifically because of what we were talking about before. That tooth morphology is very good at doing a particular thing. The reason, as I mentioned before, that bats don't have rodent-like teeth is because bats have teeth that are more like a normal mammal. They look like dog's teeth.
Yes, they do.
Like, that is good for eating small animals, insects, things like that. A carnivorous rodent, I have yet to picture how that mouth is doing carnivory.
Yeah, and some of them look like more carnivorous groups. There are shrew-like rats in the Philippines.
Okay.
And shrews are famously carnivorous small mammals.
Yeah. Shrews, for anybody out there who has been confused up to this point, not rodents.
Not rodents.
Shrews are their own thing. Those are Eulipotyphlans.
Absolutely. So they are their own group. There are some that have, the picture I found of them have a very pointed snout like a shrew.
Okay. Shrew teeth are also very much like bat teeth.
Yes, they are. They really are. There's also the racali or racali. This is an Australian water rat that are known to eat aquatic food.
I was wondering if there were any like fish-eating rodents.
Aquatic insects, fish, crustaceans, mussels, snails, frogs, bird eggs and stuff like this does seem to be kind of the order of rats.
Yeah.
Even though it's not actually, I don't know that it's actually a true rat. I don't know where this one falls out.
Sure.
But
it's a rodent.
It's a very otter-esque rodent.
Otters, also not rodents.
Not rodents. The most famous one that comes up is the grasshopper mouse. This is the one that, if you look up meat-eating rodent, grasshopper mouse will come up first. This is the genus Onychomes. They are named thusly because they eat a lot of insects. They're also known to take down scorpions and even other small mice. They will eat plant material, but a very small amount of their diet is made up of plant material.
Sure.
They have a notably more robust body. They still, like, at a glance, just look like a mouse to us who aren't specialized, but proportionally to other mice, they are more heavily built. They have a shorter, more thick tail, but they are still quite agile, and this larger build actually allows them to take down prey more efficiently. They're found in shrublands and deserts and grasslands in the western United States and northern Mexico. The northern grasshopper mouse does make it up into the Great Plains of Canada, but they're mostly in the US and Mexico. Some areas they're also called scorpion mice, usually in regions where scorpions are more common and therefore a more common part of their diet. They've also been recorded eating lizards and birds. They are by far one of the most aggressive carnivorous rodents, and their anatomy shows it in their jaw. They have a more forceful bite than their close cousins, the deer mouse. Their stomachs are also specialized to deal with the sharp edges of the exoskeletons of the insectoid and scorpion prey that they're eating. They also have sharper claws. Their group name actually means clawed mouse. Mm-hmm. And it's thought to provide a better grip on the slippery prey they're going after. And they have adaptations and behaviors to take care of the defense mechanisms of their prey items. They are known to neutralize the stinger of scorpions by biting it off. They also have a resistance to the venom of scorpions. The ion channels, one of the ways that nerves send signals, bind the toxins to block the pain signals that the toxin would give. So it kind of just neutralizes at least the painful parts. They also eat things. There's the pinnacate beetle, which has a noxious spray that it uses, and they'll bury the end of the abdomen that does the spray, so they can take it down without getting sprayed. So they are specialized carnivores. They're not just a mouse that's eating a lot of meat.
Right.
They are adapted to hunt. Another fun way, just really quick, that rodents are super diverse in weird, crazy ways is social behavior. Mm-hmm. Most rodents are semi-social. They live in small groups. There are some solitary rodents, the edible dormouse, which you mentioned back in the hibernation episode, evidently are mostly solitary.
It makes them easier to eat.
Yep. It's that way you can just
grab one at a time.
You can just have one, exactly,
yes.
So that you're not tempted to have the whole family. Many rodents live in family units. This is very common in larger rodents, where you have parent and offspring. Beavers are famous for this, where they have the parents, that year's offspring, often last year's offspring, and sometimes even some older offspring. So that you might have multiple generations living together. Brown rats are famous for living in small colonies with like up to 6 females that share a burrow or system, and then a male that guards the territory. Ground squirrels are famous for being very social. They form colonies of burrows that they live together. The burrows don't typically connect. It's still like individually family burrows, but they'll live in an area and they'll help each other by like signaling for predators.
Right. They live in a neighborhood.
Yes, exactly. It's a neighborhood. They have an HOA and everything, and they'll defend it. They'll even like share food, has been noted with them. And then rodents, unique among mammals, go all the way up to full eusociality. Mm-hmm. Like bees and ants, there are rodents that live in true colonies where there are mating individuals and non-mating individuals, but they work together as a unit. Mole rats are the rodents known to live this way. The naked mole rat is the most extreme. These can have colonies that can go up to like 80 mole rats. There's one breeding female and then like a handful of breeding males. The rest are smaller and sterile. Mm-hmm. So not just not mating, can't mate.
Right. Like ants.
Like ants. They function as workers, like ants. There are some like intermediate ones that can step in to become breeding if need be. There's also other mole rats. The naked mole rat's not the only kind of mole rat. The Damaraland mole rat also forms colonies with a single active reproductive male and female. The rest are still reproductively capable. They just aren't reproductively active.
Right. They're not allowed.
Exactly. But if given a chance, they can become fertile and go form a colony of their own. Rodents also range in size quite extremely. Not evenly across the group. Most rodents are quite small, but there are a number of larger members that give them a surprising size difference across the group. The largest rodent today being the capybara down in South America. These can grow up to weighing 50 kilograms, so 110 pounds, which is hefty.
Huge for a rodent.
That's pretty heavy for just an average animal.
Yes.
If I encounter,
that's big for a dog.
Exactly. If I encounter 100-pound animal, I'm impressed.
Yes.
Period. Regardless of what kind of animal it is. This is...
I know a lot of humans that don't weigh that much.
Yeah, exactly. This is 60 times more massive than their closest living relative, rock cavies, and 3 orders of magnitude above the mean body size for the order.
Yeah. Well, yeah, because the typical rodent body size is like a mouse.
Yes. What I found was most rodents weigh less than 100 grams or 3.5 ounces.
Yep.
Meaning that a capybara is roughly 2,000 times more massive than a common mouse.
Yes. It's a mouse with the strength of 200,000 mouse.
Yes. So it's one of those where rodents aren't necessarily the smallest animals or mammals, and they're not the biggest animals or mammals. But the size difference between the smallest and biggest member within their group is one of the biggest size ranges, and I think might be the biggest size range in modern mammals, not including fossil members.
That sounds like it probably is. Except maybe cetaceans?
Yeah, maybe.
That might be who are cheating?
Yep.
I was about to make a joke about how that capybara doesn't have to worry about my snake comment.
Right.
Because but no, capybaras actually do live alongside anacondas.
Live in the wrong part of the world to take advantage of your size there, buddy.
No, so sorry. Capybaras are delicious.
Yes, they are.
I assume.
Yep.
I have not tried one.
We raise them, like humans raise them. So
I have not eaten a capybara.
I'm sure they taste great. There are other South American rodents that also get notably big, just not nearly as big as the capybara, but South America is full of surprisingly big rodents. Quick note on South American rodents. Evidently, the chinchilla has the densest fur of any land mammal.
Huh.
Yeah. Well. Just for a little superlative for rodents. And then to wrap up our first section, the weirdest thing I found out about modern rodents. This is, at least for me, this was my favorite thing I learned. And this should really have gone back when we were talking about how cool their tails were, but it's so weird it has to wait till the end. African spiny mice have osteoderms on their tail.
That's right. This is a thing that I knew.
Yeah. And that's not even the weird part.
So osteoderms are bony armor.
Yes.
That typically we think of, that's something we see in lizards, that's something we see in crocodilians, armadillos.
Yes. Not unknown among mammals.
Not unknown among mammals.
Very rare among rodents.
Sure. And usually it's not just the tail.
Yes.
Usually you've got them all over.
To my knowledge, I didn't see them mention any other osteodermed rodents. I think this is the only one we know of to have osteoderms.
The only one I know of.
It is very fine, small osteoderms down their hairless tail. That is not their only weird feature. They also are surprisingly good at healing. When they're injured, they heal without a scar. Which is not how mammals heal.
That's not how it works.
Yeah. Other animals, amphibians and reptiles, are more known for healing without leaving a scar behind. That's not a typical thing for mammals.
Also, osteoderms are not a typical thing for mammals.
They can regenerate skin, muscle, nerves, and even spinal cord, maybe cardiac tissue. Like, they're looked into heavily for medical research because of this. But their skin is also particularly fragile. So it tears easily, heals well.
Okay.
They also are known to commonly lose their tails. Similar to how lizards can lose their tails as a response to predators, in a particular way of losing the tail called degloving. Yeah.
No.
Apologies, everybody.
No, this is terrible.
The outer layer of skin can easily come off the tail, allowing them to get away from a predator attack, leaving behind just the muscle and bone, which typically the mice will chew off because they cannot regenerate all that skin. So they can't grow back the tail.
So they don't lose their tail like a lizard
might.
They lose the skin off the tail.
Yeah.
Which renders the tail a liability, so then they chew the tail
They
off.
amputate the tail.
That's ridiculous.
Yes.
That's a terrible choice. Why? Why? That's so much worse than there are so many reptiles that are doing that in a way that makes so much more sense.
Yeah, the paper I read did make the point to say they can only perform this once.
Yeah, this trick, it can only do this trick once.
It's the greatest trick in the world.
I was gonna say, but when we were talking about osteoderms and their healing without scars, I was gonna make a joke about, like, are we sure these aren't just, like, reptiles pretending to be mammals? But no, reptiles know better than that.
All right?
That's nonsense.
This leads to the question of why armor a tail that you're going to deglove?
That is also a very good question.
Right? How is that? The possible explanation, this is all fairly new discovery,
Sure.
like within the last handful of years that we found out they had osteoderm. It was found out by accident, CT scanning and going, hey, the bones in the tail.
Yep. I think that's what happened with, like, Komodo dragons. It was like, yeah, we CT scan them and wouldn't you know it.
There's a lot more pings on the radar. There is a gecko in Madagascar, the fish-tail gecko, which, unlike most geckos, does have osteoderms. It is also covered in thin skin that is very fragile, just like the spiny mice.
Okay.
Their skin also sheds at the slightest provocation, as the paper put it.
Okay.
The thought is that the osteoderms in these two groups might be a way to ensure that only the skin is grabbed and the teeth don't penetrate through the skin to the muscle, which won't come off with the degloving. So that way I bite, I just grab your skin because I can't penetrate the bones.
Right.
You slip your tail out of that glove that I'm holding and get away. I wasn't able to actually get a hold of your tail well.
Okay, that makes sense.
Yeah.
I also, it made me wonder if the osteoderms are helping to keep all that skin together.
Yeah.
As it gets, so it comes off in one go.
Exactly. And so that's the weirdest thing I learned about rodents.
Here's what I would love. We've been doing this podcast for over 200 episodes. I would be thrilled if the word degloving was never used again.
Did I use up my one?
That was it. This was your one.
That was my
like
one
a
chance.
PG-13 movie. That is a word you get to use once. That's awful. This is an audio format, so the listeners could not see the face I made when you... Because I was like, because like in lizards, it's autotomized.
Mm-hmm.
Autotomy is the intentional losing of that part of the body. And I was like, is there like a specific term for it? And no, it was worse. It was worse than I expected.
Well, it's a term that's usually used in industrial accidents.
Yes. Well, yeah, I know it because I've worked with people who are like taxidermists and anatomists. It's like, yeah, that's how you skin a snake.
Yeah, I learned it because of machinists.
Yes. That was terrible. Voluntary degloving.
There you go.
Ugh.
I think that's enough talking about living rodents because they are disturbing.
That's quite enough of that. This episode does come out in October.
Yes.
So we are still...
Spooky.
We will remember the degloving tail mice for future seasons of Spooky. Oh, this is the worst episode.
Yep. Let's take
This is why we didn't do a rodent episode.
Yeah, if everyone...
For
why
8
did it take
years,
them so long?
This is why.
We had to build up the
We
courage.
don't want to talk about this nonsense.
Let's take a break, and when we come back, talk about rodent evolution, rodents in the past, and how extreme some of them got. Getting into the fossil record is by far the best way to demonstrate what we mean when we say rodents are kind of the default mammal. Many early groups of mammal look extremely rodent-like.
Yeah, this is very much the same way that many early groups of reptiles look very lizard-like.
Yes.
That is sort of the basic blueprint.
Yeah. Like, there's not actually a default to a group of life's body plans. But we do see some morphotypes that seem to be kind of the common denominator for surviving on Earth.
Right.
And rodent seems to be one of those common shapes. Some of the earliest mammal fossils we have basically look like mice. They are not. They are not mice. But there are many members that show up. You will see rodent-like show up in many descriptions of many early groups and just groups throughout the Mesozoic.
Well, and in much the same way that there are a lot of animals today, a lot of mammals that are not rodents, but shrews, moles, a lot of things that are very like rodent. That body shape, like rat, seems to be maybe the best way to be a small mammal.
Which makes sense when we look at rats and mice, which are the most prolific, most widespread, and arguably one of the most successful groups of animals on our planet right now.
Yes.
Like, they're outcompeting us in many areas. Yes. They are doing very well because that body plan works in most situations. It's kind of got the, like, if you could only have one tool, hammer would be what a lot of people, or something like this will get most jobs. This does more jobs than most other tools.
Yes, mouse does all the jobs.
The earliest record of rodents we have goes back to the Paleocene, very shortly after the end of the Cretaceous. Mm-hmm. There are some estimates that suggest that they likely might have shown up during the Cretaceous, but some of the estimates also just agree with the fossil record, that they showed up after the Cretaceous, very soon after, but early Paleocene. Truly the beginning of their history, their story begins with the clade of Glirus, them and logomorphs. This clade seems to have diverged from other mammals around 60 million years ago. The earliest members were neither rodent nor logomorph, something in between, something that had not yet split, had not given rise to those two lineages. The first true rodents show up later in the Paleocene, more toward the end, that, like, for sure we confirm this is indeed a rodent. Likely evolved from a group called Anagalids, just a group of small fossil mammals. May have also given rise to logomorphs, but that seems to be less sure.
Okay.
So that both might have come out of this group, but it seems most agree that rodents probably came out of this group. Some of these earliest lineages are only known from the fossil record. Ischiromyidae, I saw one, at least in one thing, referred to as proto-rodents. So maybe like...
Okay.
But like these
rodent-like, but not quite there yet.
Yeah. I also saw some call them some of the earliest rodents. So they're right there. These are only known from the fossil record. You also have the group Ctenodactyloidea, which does survive till today. It includes the Gundis, or comb rats, which are found in Africa. They're kind of stockier rodents. Most of these early rodents are very generalist in shape. You know, very rat, very mouse-like. This is mainly based off of the heel anatomy, that it seems like they're probably moving around like you think of the average rodent moving around. They're thought to have evolved in Asia. This is based off of mostly the fact that the earliest Glirus fossils are found in China and seem to have then expanded their ranges into North America and then into Europe from Asia. But the first true rodent fossils are found in North America in the latest Paleocene, which kind of contradicts, so it's not quite clear for sure.
Sure, it seems the ancestors of rodents showed up in Asia, but then rodents showed up in North America.
Yeah.
Which could be true.
Yes, that might have been how it happened.
But yeah, we might also just be missing pieces.
Exactly. Most of the papers I found said that the current stance is that they started in Asia.
Okay.
But exactly how they got to North America, where we first find their record, we're not positive. Moving into the Eocene, we see rodents begin to diversify.
This is around the same time that we're seeing the diversification of like bats, primates, a lot of our modern mammal groups.
Absolutely.
Around 55 million years ago.
Beavers start to appear in Eurasia in the late Eocene. They later show up in North America in the late Miocene. This is also when we see the Hystrognaths invade Africa and become the African group that they're now known as. Once again, probably originating in Asia beforehand. Some of these, which would go on to become the cavomorphs, colonize South America from Africa.
Yes, we talked about this sometime in the distant past. I know this came up in episode 7 with Ethan, with primates, that both primates and caviomorph rodents at some point made the trip across the Atlantic from Africa to South America.
Yes. The earliest caviomorphs we have in South America are about 41 million years old.
Okay, so still in the Eocene.
Yeah. Suggest at least their origin in Africa, that far back, maybe farther.
And it's easy to imagine how rodents could make the trip across an ocean. Yeah, hanging on to a floating mat of vegetation or something. A much easier thing to picture than for some other groups of animals.
Absolutely. They reached the Greater Antilles by the Oligocene and then spread across South America. One notable group of fossil rodents I came across were the paramyines, which are the most abundant rodents in the Eocene of North America.
Oh.
This is a big deal group in the fossil record, typically compared to sciurids, squirrels, probably like ground squirrels, your groundhogs and things like that. Sciurids are often considered one of the more primitive groups of rodents, so makes sense that a fossil group resembles their lifestyle very closely. Later members of this group are characterized by being larger in size, not gigantic, but biggish rodents. One that I saw noted was Menechatanka, which is the largest member of this group, and his skull was 50% bigger than today's beaver.
Whoa.
So
that's big.
That's pretty big.
Because beavers, we didn't really mention this before because we got distracted talking about capybaras.
Yep.
Beavers are huge.
Beavers are big rodents.
I want to say beavers are like the second biggest.
Yes, I believe they are
rodents.
for weight, the second biggest rodent today. These, though, have forelimb morphology, forelimbs that shape more for digging.
Okay, so this is like a groundhog.
Yeah.
But bigger than a beaver.
But it's unclear for sure. It was described that they could be suited for digging, maybe climbing. There have been suggestions of semi-aquatic.
Okay, so it was doing something.
No direct support from one of these, but
sure.
It has some specialized forelimbs that seem like they were doing something interesting. Most think it was probably terrestrial because it was big.
Yeah.
You're probably just walking because you're big. As we move through Oligocene, we said South American rodents are doing their great diversification to become the crazy assemblage of rodents that they are now. In the Miocene, we see a lot of the members of current families start to show up. So about 20 million years ago, most recognizable rodent groups had shown up or were showing up. The mouses were here by now. Very modern-looking squirrels had evolved. And during this Miocene, when Africa finally collided with Asia, is when we see African rodents begin to spread back into Eurasia.
Oh, okay.
And
interesting.
stuff. Because things like the porcupine evolved in Africa, and then...
Right. Those ancestors came, presumably, from Asia into Africa, spent several million years giving rise to porcupines and stuff.
Yes.
And then those then were able to spread back out.
Yeah. Look what I made with the stuff you gave me.
Look what we did. Look what we turned up. Don't step on it.
Why does it hurt so much? We didn't even mention porcupines particularly. Porcupines.
Yeah, porcupines.
The quilled, sharp-furred mammal.
Also porcupines.
Rodents.
Africa's down there like, you won't believe what this one's tail does. And Eurasia said, you keep that one.
Yes. Yep.
You keep that with your weird geckos.
Yeah, no, we don't want them. In the Pliocene, the murids, the mice, start their radiation.
Spread like rats.
Spread like rats. And the colonization of them globally is extremely complex. One paper mentioned that from the data, it suggested that there have been up to 7 colonizations of Africa, 5 of North America, 4 of Southeast Asia, 2 of South America, and 10 of Eurasia. So,
and this is like
separate invasions.
Not including
what we did.
When we then brought them everywhere.
This is fossil that they were spreading out across the world, but it wasn't like, and then mice went to Africa.
Right.
And then these mice went to Africa. And then later these mice went to Africa. And then later these rats went to Africa. A little bit after that, these mice just... That, like, totaling that
waves.
up, we're over 10, I think we're pushing 30, different spreading out events across the globe. Most notably, as we mentioned, they're the only land mammals, placental mammals, to make it to Australia by themselves.
Yep.
The first rodents arrived in Australia via Indonesia, around 5 million years ago. The earliest fossils have an age of about 4.5 million years, so the estimated is 5. All belonging to the subfamily Murinae. And this is interesting. There's about 50 species of old endemics, which is the first wave of colonization into Australia in the Miocene and early Pliocene, and then 8 true rat species of new endemics arriving in a wave, still not with us, in the late Pliocene and early Pleistocene.
Yep. And then in the late Pleistocene, they colonized with the colonizers.
Yes, exactly. Pleistocene rodent fossil records are also super important. Like, they're very diverse. They're going to include most of our modern groups and a lot of our modern members, but they're also very important for, like, dating.
Yeah.
Like, dating fossil layers.
This is one of the, like, if you're digging at a fossil site, especially a more recent, Pliocene, Pleistocene fossil site, you have to get someone to identify all those mouse teeth.
Yes.
Just tons of these little rodent teeth that are often very identifiable.
Yeah.
Some of the earliest fossil material that I worked on, I wasn't working on mice, but I know a bunch of these names.
Yep.
Like I know Peromyscus and Neotoma and all these names because I worked with researchers who constantly were talking about these rodents.
Yes.
They're so important for characterizing ecosystems and time periods.
Well, they've got the same thing that like ocean plankton and diatoms has, is that they're numerous, they're everywhere.
Yep.
So you're very likely to have rodent fossils in a fossil site that
Also,
was during the age of rodents.
It's teeth.
It's teeth.
So they fossilize really well.
They also are small animals, so they're very often a single species might have a fairly restricted range, which can make them very good for identifying habitat and location. They also evolve quickly, so species don't often last for huge stretches of the fossil record. They evolve into a new species fairly quickly, so you can say, this species only lasted for this 3 million year period.
Yeah, they make good index fossils.
If we have that mouse, it has to be between these 3 million years.
Also, as we've been discussing, so many of them are good at burrowing.
Yeah!
So they just put themselves right in the ground.
I had a friend text me the other day that asked, if you bury a body, would it be more likely to fossilize? And we got to go into a whole conversation about that. Yeah.
I was like, yeah, yes.
They help you get underground. So, super useful. Like, not only are they full of cool fossil rodents, but also very important just for studying the fossil site you're at.
Yeah. You can, as a paleontologist, make your entire career just studying fossil rodents, and there are many who have done that.
Yes, absolutely. Now, we are not going to go into all the various fossil groups and, like, the evolution of each of the clades. That's too broad for this overview of rodents. But wanted to get some of the highlights and famous fossil members and groups. There are some notable fossil rodents that stand out from the rodents we have today. Rodents are diverse and weird today. They were equally so in the fossil record. And some of them we don't have anymore, and we don't have examples like those anymore. One group that is super weird today, and arguably just as weird or weirder in the past, beavers.
Yes.
Beavers. Beavers a super weird rodent to just on the face. They're aquatic, which most rodents are. They have a flat tail. They eat wood, which is a hard thing to do for any animal.
And they're also architects.
They make homes. They reconstruct. They landscape by making water features.
Yeah.
Very extreme. They're also one of the few case strategist animals in that among rodents in that they don't have lots of babies.
Yeah.
They have a few and raise them very carefully. So they're one of the few rodents that does that. And that sets them apart. There are a number of interesting fossil beaver groups. Most were not aquatic. Most beavers did not start out that way. They start out just as land rodents. Many of them were burrowers. There were also, we mentioned how the beavers, the second biggest rodent today, they were also some of the biggest rodents in the past.
They sure were. We did a panel at DragonCon this year that had the term giant beavers in the title.
Yeah, we did.
It was about Pleistocene animals.
Castroides, the giant beaver. This is a North American Pleistocene beaver. There are 2 species currently recognized, one in the southeastern U.S. and one that's throughout most of North America. Much larger than modern beavers, today's beavers weigh on average about 9 to 42 kilograms. I forgot to get the poundage for that.
That's like up to 80 pounds or so.
Yeah, which is hefty.
That's huge. Again, that's a big dog.
That's pushing the capybara.
40 kilograms.
Yeah,
Jeez.
42 kilograms. So, beaver.
Yeah.
The
a beefy beaver.
A beefy beaver. The average length of Castroides was approximately 1.9 meters, 6.2 feet.
Sure.
Which could grow up to 7.2 feet, 2.2 meters, and could weigh between 90 kilograms to 125 kilograms, or 198 pounds and 276 pounds. That's a beaver that up at its upper range outweighs me.
Yeah.
That is a beaver that I would have trouble giving a piggyback ride to.
Yeah, that's a beaver that's approaching, like, black bears.
Yeah, that's often what they're compared to is black bear. Like, this is a big beaver.
That's huge.
Largest known North American rodent during the Pleistocene.
Not the largest known rodent.
No.
I assume stay tuned.
Yes.
Because I know what the largest known rodent is.
Yep. This is the largest beaver by far, and one of the largest in North America. Heavily debated how much like our beavers it behaved.
Right. Whether they were building condos.
Yeah, exactly. Like
chopping down redwoods and building enormous
skyscrapers. There are seemingly some pieces of evidence that suggest they might have been aquatic, or at least semi-aquatic or something.
Okay.
The hind feet were much larger than today's beavers, even though the hind legs were shorter. So there does seem to be some evidence that those would be good for paddling. Mm-hmm. It's often considered that they were a swimmer and probably pretty clumsy on land based on that anatomy.
Like modern beavers.
Yep. So seems like they should be able to swim based off that. Their tails were longer. It's unclear whether they were paddle-shaped.
Yep.
Because
that's harder to tell just from the bones.
That paddle shape to a beaver's tail is mostly soft tissue.
Yes. I believe that beavers, and I might be thinking of a different group of animals, but at least some animals with paddle-like tails, the vertebrae themselves are also flattened.
Yeah, they are flattened, but they're not as wide as the paddle is.
Yes.
Like, the beaver's tail is fairly normal tail proportions.
Yes. So you might be able to get an idea from the shape of the vertebrae, but you wouldn't necessarily be able to say, is this just a slightly thicker tail?
Yes.
Is it a full-on paddle? That's hard to know.
It sounds like here they either don't have evidence for that flattening or maybe lack the things we would look for it. Mm-hmm. We don't know what shape their tail was. Some have suggested, based off the skull shape, that it looks like they might have spent time in water because there's a pinching of the nasal passage that splits it into an upper and lower venting.
Okay.
Which, at least to one or a few researchers, suggested that might give them better air reserves, let them hold more air. Others have said that makes more sense as making space for jaw muscles and musculature.
Okay.
That is probably not breathing reshaping, but jaw muscle reshaping that you're seeing. So there's been debate there. The incisors have also given mixed data as to whether or not they would be feeding similarly to modern beavers. They differ in size. They're much longer than today's beavers, up to 15 centimeters long or 6 inches. Those are some teeth.
That's a lot of incisor.
But they have a different enamel structure. Modern beavers have very smooth enamel. The giant beaver had striated and textured enamel. So that front hard surface of the tooth that gives rodents their chisel-like teeth, their surface of enamel is distinct from modern beavers.
Interesting.
I didn't see specifications on what that means for their teeth.
Sure.
But it could mean that they're not doing the same thing.
Right. It would make a lot of sense if Castorides was not actually living like a modern beaver. I wouldn't be surprised if you saw it in person and didn't think beaver.
Yes, absolutely.
If it just looked weird.
Yeah. One study seemed to find evidence that they would not have been efficient for cutting wood. So they probably weren't eating wood and at least weren't making dams.
Sure.
So probably not.
There was a study, I don't remember if we talked about this in the news when it came out, but a study that a couple of our colleagues published that looked at beaver evolution in the fossil record and concluded that dam building, like modern beavers, is a relatively recent development in beaver evolution.
Yes.
So we might not expect to see that behavior widespread in the beaver extended family tree.
Absolutely. Which is one of those great examples of, by far the most famous thing about beavers today, probably not representative as beavers as a group going back in time.
Yep.
One note that also seems to support that stance is that Castorides seems to have a smaller and, based on the inside of the skull, smoother brain than today's beavers, which could indicate less propensity for that high level of complex behavior.
Right.
That you might not have quite as complex a brain to do what is a very complex thing, making a house in the middle of a lake.
Right. Now I'm picturing B-Barrel.
Yes.
The Pokemon, which is that expression on its face.
Yep.
I'm not building anything. I'm just hanging out.
I'm just here, and I'm big. This is not the only notable beaver in the fossil record. Paleocastor, which ancient beaver.
Ancient beaver. Castor is the genus of modern beavers.
Also North American, found in North American Badlands. This is not... None of these beavers are the ancestors to our beavers today. Our beavers descended from beavers that came over from Eurasia. These are extinct lineages that were here in North America, I believe before that happened, before the modern beaver got over here. This is much smaller than modern beavers, often compared to the black-tailed prairie dog, which I found sizes for of 1.5 to 3 pounds, or 0.68 to 1.36 kilograms, and being about a little more than a foot to a foot and a half, 36-43 centimeters. Smallish. Not teeny tiny, but not big. Very much like the prairie dogs, these are for sure burrowers. They do not show signs of being aquatic. They seem to be actually, in body shape and anatomy, much more like ground squirrels and much more like groundhogs and prairie dogs and things like long body, burrowing limbs, small ears, short legs. These seem to be classic burrowing rodent. And they were good at it. They are connected with one of the most famous fossil stories.
I was like, why are we talking about paleocat? All right, yep. I've caught on. I've caught.
There was, in the 1890s, a series of odd structures found out in Nebraska is where it was quoted for being first found, but out in the Badlands of the U.S., these structures in the ground that were big corkscrews of sediment that obviously were some sort of fossilized thing, but no one could figure out what they were. They were also baffling because some of them were huge, 3 meters long, down into the ground. So like 10 feet. They first became famous when paleontologist Erwin Hinckley Barber started working on them and found them in 1891 and started trying to describe them. Spiral sand-filled tubes, often covered or lined in a fibrous material. The first explanation was giant freshwater sponges.
Sure.
Because they had interpreted that the sites were freshwater lakes.
Right.
But not everyone was on board with that because
it's wrong.
Because it's wrong, and that's a very extreme.
Yes.
A giant freshwater sponge that would be a very unique fossil organism, period. It was given an ichnotaxa for trace fossils of Daemonelix, which translates to devil's helix.
Yep.
Or devil's corkscrew.
Devil's corkscrew is the famous name of this trace fossil.
Yep. And despite us now figuring out what they are, and it now no longer really needing that specific designation the same way, the nickname has stuck.
Absolutely.
Because that's great. Over time, many more were unearthed. Examination of the rocks showed that they are actually arid environment, so not freshwater, which led to the new hypothesis that they were some sort of giant plant.
Sure.
Like a root system or a giant root or tuber or something, partially due to that fibrous material found on the outside. The key smoking gun was that many of them had rodent remains in the tubes of sand, preserved at the bottom or in chambers, because sometimes they would have multiple chambers. Looked very much like a prairie dog, and it was eventually identified as Paleocaster. Yep. 2 years later, Edward Drinker Cope identified that these must be burrows. These were the burrows of Paleocaster that dug deep spiral burrows. And as we mentioned, tons of burrowing rodents nowadays. Many of them make very intricate, expansive burrows underground. This is just a very unique shape of burrow.
Yeah.
Not only are the burrows unique among burrowing rodents today, there's also evidence that shows that Paleocaster, like today's beavers, was probably more family-oriented than fast breeding, that they were case strategists instead of R strategists, which sets them apart from most other burrowing rodents.
Yeah.
Whether that's connected to their unique burrow is hard to say, but they do seem to be unique in a couple of ways in the way they're doing the underground rodent gig. It's been suggested they might also have lived in towns like prairie dogs, mostly due to a find that had at least 200 burrows in a close area.
Whew. So something ghost town.
Right? Exactly.
It's a joke, and the punchline is ghost town, and I don't know what the setup is.
It's a ghost bar with all the corkscrews. The twist of the burrow might be due to them living in an arid environment and basically keeping airflow down so that the hot air didn't move down into the burrow.
Oh, sure. Yeah.
And kept things cooler down in the burrow more efficiently. It also could for sure be for just making it harder for predators to get in.
Yep.
That if you're not small and flexible, then you can't reach your stiff arm far enough down to grab me when I run away from you. There's also
maybe they had one incisor bigger than the other one, so they
were trying to dig a normal burrow.
Spiral. Yeah, it just happened that way.
So why does this keep happening? Gosh. There are evidence of multiple burrow chambers inside some of the burrows that have been suggested, and I think there's some evidence of like living quarters, nurseries, latrine, like might have had designated, very complex living arrangements. There's also evidence that they were digging both with claws and teeth, very much like naked mole rats, because there's straight marks from teeth, but definitely ones from claws, so we have evidence of how they were making them. And I found one thing talking about them using for predators, that at least in one, there were the bones of a primitive weasel named Zodiolestes that was associated in one of the burrows. That seems like it might have been chasing or checking one out.
Yeah, your spiral burrow is not going to keep a weasel out.
Nope. And so that, and it's, as I said, it looks similar to today's weasels, and that's what today's weasels do, is go, yep. Oh, you've made a tunnel for me. How convenient. Let me come say hello. So Paleocastor is pretty cool.
Very cool animal.
Very cool. Not the weirdest burrowing fossil rodent. They get weirder. There is a group of rodents known in North America and Asia, the Mylagolidae. This is within the Sauromorpha, so this is within squirrels and their cousins. So these are kind of fossil ground squirrels, but not actually in that same group. They were around from the late Oligocene, around 29 million years ago, and the youngest go all the way up to the Pliocene, about 5 million years ago. Not a lot is known about their body anatomy, but we do have some skulls and cheek teeth. Their skulls are unique. They have very thick nasal bones, so the bones above the nose, and are very short and broad, so just very robust, thick-set skulls. They're famous because they have horned members. Not all of them are horned. I saw one paper say 6 that are known to be horned of the roughly 30 to 35 species overall. They had 2 horns on the nasal bone. The nasal was expanded into a pair of horns. One paper, in quotes, absurdly like that of a miniature rhinoceros.
Yes. Just this pair of horns sticking off the snout.
They are the only known horned rodents, and evidently the smallest horned mammals.
Oh, interesting.
Yeah.
That makes sense.
These are not particularly huge. They're robust, so think like groundhog. They're not tiny mice, but they're not in the upper ranges of rodent sizes. The horned members are some of the larger members. All of them are in the larger sizes. They don't include the largest myogalids, but they do include some of the larger members. The genus Ceratogallus, the horned gopher as it is often known, is the famous group for this. At least I saw 3 of the 4 in one paper, but it sounds like the exact number of how many species are horned has gone back and forth, and how many of these species are in one group has gone back and forth. So Ceratogallus for a long time was known as the only horned rodents. There are a couple of other genera that have been found with species. Whether or not those are in that genus or in Ceratogallus has shifted over time, but Ceratogallus is the famous one. They're all from the Miocene and early Pliocene. Here in North America, specifically the Great Plains, Nebraska and Colorado. It seems like these horns likely only evolved once in this group, so they are all related to each other. And they start with shorter horns and get longer over time. The purpose of these horns is hotly debated. We do not know for sure why they have these horns. Part of the confusion is that they are from a lineage of burrowing rodents. And even though they seem to be potentially less fossorial, less digging than the rest of their cousins, they still evolved from burrowing rodents. They still seem to have signs. Their head is still shaped like some other digging rodents that we know. So there are some more expected explanations for the horns of like sexual competition, maybe species recognition, defense against predators that are just normal horn explanations, but there have been many suggestions and research into were they for digging? Mm-hmm. If you are a digging rodent and you have horns, were these for digging? Part of the reason this is suggested is there is a form of digging known as head lifting. Most rodents dig with their teeth or their claws, but there are head lift diggers, both in today's rodents, as well as armadillos and some moles, where basically they use their head like a shovel to scoop and push the dirt out of the way. And these horns are in the right place to be kind of like a pickaxe and scoop into the dirt and break it up. So it's been suggested, were you using these very unique horns to build your burrows or to help you build the burrows? There are plenty who look at this idea with skepticism because A, Headlift digging is not the most common form of digging in rodents. Most use their teeth or their claws. Also, horns and digging are very rare features to go together. In fact, horned gophers and the fossil armadillo, Peltophilus, from the Miocene in South America, are the only known horned animals to also dig. So it's just, there's a lot of reasons to not associate them together, but it also does seem like they were probably a digging rodent that had horns, so it's just a very weird combination. Most think that the simplest explanation is probably the most correct, that they were probably defensive. The evolution of the horns, with them getting taller over time, also goes with a increase in body size, which likely would have made them less adept at being just a strictly burrowing and underground animal, because you have to make bigger burrows now. Most underground animals are fairly small. This probably meant that they were spending more time on the surface, and if you're going to be more exposed to predators, having bigger horns and defenses makes more sense.
I remember reading a description hypothesizing that these would like back into their burrow with the horns facing, so that if a predator tries to come in, the first thing it gets is horns.
Yes, exactly. So probably something like that. That's what you would expect for horns. Maybe also for fighting off rivals. It is not unreasonable to think they could have used them for digging, but I don't know that there's any evidence other than the fact that the shape for myogallid heads are similar to headlift diggers.
Sure.
So as a group, it seems like they likely were probably using head digging overall, but whether or not the horns were related to that is still very unclear. But yeah, horned gophers.
Horned gophers.
Super weird. Hasn't happened again in rodents for some reason, because I guess we're being punished. Because, man, that would be cool. And then the last cool examples of fossil rodents I wanted to go over are South American giants. South America is full of cool rodents. There is not enough time in an episode going over rodents to actually go over how cool South American rodents are. But, most notably, South America has the biggest rodents. Both today with the capybara, but cavomorphs, which includes the capybara as well as its cousins, things like guinea pigs, chinchillas, pacas, pacaranas, spiny rats, the New World porcupines, and nutria, many of which are famous and well known in their own right. These are not the only South American rodents, but they are the famous bulk of the wide diversity of South American rodents. They include digging forms, semi-aquatic forms, arboreal tree climbing members. As we mentioned, they showed up in South America around the Middle Eocene and then experienced a huge diversification in South America. And in numerous groups, giants evolved. There are numerous lineages of cavomorph rodent that got huge, like the capybara, but dwarfing it. One group, Neoepiblemidae, had one large member that for a long time was heralded as the largest rodent until a more recent discovery. One genus, which is Phoberomys, and specifically the species Phoberomys pattersoni, is a rodent known from Miocene of Venezuela and is the largest Neoepiblemid. Current analysis suggests that it's closely related to the group Diomys, which is the today's Pacarana, which is itself a fairly sizable rodent. This rodent, initial body mass estimations, put it at somewhere between 436 to 741 kilograms.
That's so big.
So big. That's 960 to 1,600 pounds. It's like a horse.
Yeah, that's half a ton of rodent.
Yep. This made it the largest known rodent, 10 times larger than the capybara, today's largest. It made rodents one of the mammalian orders with the largest size range, second to diprotodontians, marsupials. Later studies brought that size range down. That initial one was based off the dimensions of the femur, the leg bone. Later studies looking at the skeleton found that they have a disproportionately thick femur, that just their anatomy is thick leg bones. So going off of that measurement gives a bigger size than the actual animal would be. Body mass based off the skull put it at a mere 150 to 250 kilograms. So 330 to 550 pounds.
It's only a quarter of a ton.
Still like a white-tailed deer. Like, still way bigger than any rodent today. massive. That's still 5 times as big as today's capybara. Still massive. Still would have been the largest rodent we knew of until we found another in the family Diomyidae, which is the group that includes the Pacarana, which is the only member of it in that group today. They can get up to like 15 kilograms, 33 pounds, 2.5 feet long, not including their tail. Fossil members got big, and specifically, one species in particular, Josephoartigasia monesi, has been described as a Pacarana with an estimated body length of 3 meters, 10 feet long. The skull dimensions and body size were initially estimated for a weight of 468 to 2,568 kilograms, or 1,032 to 5,661 pounds.
So 2 tons.
Yep. Once again, there were revised estimates.
Sure.
Based off of the tooth size. These yielded much smaller values of only 356 to 651 kilograms, or 784 to 1,435 pounds.
So half a ton.
So its downgraded size is at the same size as the initial large estimates for Phoberomes.
Yep.
This is now the largest rodent that we know of.
Yes. That's a tapir.
That is huge.
That's enormous.
That is massive. Both of these seem to be herbivorous. Mm-hmm. I didn't find as much info on Phoberomes as to like anatomy or lifestyle and stuff. Just I don't know if that's known or not. But high-crowned molars, so tall back teeth, suggest that it was a specialist herbivore, which makes sense for such a large animal. Josephoartigasia seems very similar. I did find some interesting things about it. It has a reinforced skull and large, strong incisors. There's a big diastema, the gap between the front teeth and the back teeth. This is very common among, like, the proportionate size is very common for rodents going after tough food, like nuts or wood, or digging. So probably it was going after tough food. They said it could have been like digging up roots and going after them. It has been suggested it could be excavating burrows, because there are some mega burrows down in South America. But there's also other things that could have been digging those burrows, so we can't say for sure that it was this rodent. They also have estimated what the bite strength based off the skull and teeth would be, and it is an estimated 799 to almost 1,200 newtons, or 180 to 270 pounds force, which is comparable to many large carnivores. I saw the polar bear noted. Like, this is an extremely powerful bite. So either it was chomping into really tough stuff, or eating very tough food that it had to grind down. Others have also pointed out that it could likely be a tool of defense. Big front sharp teeth and a strong bite, because South America was full of large predators at this time. You might have just been using this kind of like a hippo uses its big sharp teeth, is to fight things off. They also have been able to do carbon isotope analysis of the enamel to look at what sort of food they were eating, what kind of isotopes and molecules were being left behind on the teeth and grown into the teeth, and reported that they ate only C3 plants, which is like leaves and fruits, versus C4 plants, which is grasses, which is very similar to today's capybara, which also mostly eat C3 over C4, and typically only eat things like grass in leaner, tougher times. So it could likely be that they were basically living like a big capybara, mm-hmm. and just browsing around on the trees and fruits, just, the size of a horse.
These would have had less to worry about from anacondas.
Yes.
Now, this is what you want to be like when you're living in an area with anacondas.
Yes, absolutely. That's the correct size to be. And the last fossil group I want to mention is not actually rodent, but are often discussed when talking about rodent evolution and fossil rodents. The multituberculates are a famous fossil group. These were the most diverse mammals during the Mesozoic. So they were very much like today's rodents are now, but during the age of dinosaurs. More than 200 species are known. They ranged from mouse size to beaver size, so there were some decently sized members. And they seem to basically have been living very similar lifestyles to today's rodents. There are burrowing members, there are tree climbing ones that seem very squirrel-like, there are even ones that seem to be hoppers. Their teeth and skull shape are very similar to rodents. They have large, procumbent front teeth. separated by a wide gap to the back cheek teeth. So like very similar to the incisors and diastema of rodents today. They do have differences, of course. Their teeth have lots of bumps on, the chewing surface, the tubercles, which is how they get multituberculate as their name. They also have a crazy premolar on the lower jaw. That's just this big blade-like, extremely oversized premolar that's very specialized to them. They were one of the most successful orders of mammals. They were around for 130 million years from the Middle Jurassic to the Late Eocene. The reason they come up is not only are they similar to rodents, but it has often been asked why, if they were so successful, did they peter out? And is it that rodents came along and were doing the same job, but did it better, or did it in a way that pushed multituberculates out? Part of the reason this question has come up so pointedly is that they made it through the end Cretaceous and were doing actually quite well. They reached their peak diversity in the Paleocene. So they were actually doing better after the end Cretaceous, even though they went through it. But then as we move through the Paleocene into the Eocene, their numbers just slowly dwindled until they went extinct. This is the time period, as we mentioned earlier, that rodents seem to first evolve at the beginning of the Paleocene and then diversifying in the Eocene. There does seem to be some correlation between the spread of rodents and the fall of multituberculates. This is controversial and debated, so it is not clear, but there are some patterns that seem to match, some patterns that don't. Interesting notes I found were that in Asia, where it's thought that rodents first evolved, multituberculates were more heavily affected by the KPG, the end Cretaceous extinction there, and they never fully bounced back to their numbers and diversity in that area. This is unlike their relatives in Europe and North America, so those parts of the world, they were still doing quite well. Asia, they seem to get hit harder. It's thought that this might have resulted in a vacuum, so to speak, a power vacuum, an ecological vacancy, allowing rodents and their relatives to fill in the spaces now left by those multituberculates that had died back a bit. This might have taken up space that didn't allow multituberculates to reach their numbers again. That might have been why they didn't bounce back there. It is also noted that the American and European groups of multituberculates do go down in diversity when rodents make it there. So there does seem to be a correlation.
Interesting.
But others have pointed out that the multituberculates that did survive in Asia survive alongside rodents for another 15 million years and don't seem to be, they're stable pretty much during that time.
So it's not quite as clear a correlation. It's not that when you have rodents, multituberculates suffer.
Yes. This is often called the competitive exclusion hypothesis, that they were both doing the same kind of job, and that if one was doing it, it excluded the other from being able to do it and pushed them out. Most have pointed to their dentition being so similar as probably the key thing. But one study found some interesting results in that. They did digital models of rodent skulls and multituberculate skulls to look at, were you better at doing the biting, chewing, whatever jobs than multituberculates? And they found that rodents had higher stresses in the cranium and jaw, and lower resistances to bending and twisting. So they don't seem like they are more efficient, better skulls at doing the same kind of job. But they are optimized for bite force production. So basically, their skulls are not good at resisting as high of stresses, but they're better at producing bite forces than multituberculates, so they don't need to resist the same stresses. So they're more, it seems they are more efficient skulls, but not actually just overall superior skulls. So whether or not rodents truly replaced multituberculates is still debated, but felt it was worth mentioning that there does seem to have been rodent-like animals going back all the way through the Mesozoic, pretty much, and the ones that were there before rodents were also the most diverse. It's a good shape to be. It's
not just that, as we mentioned before, early mammals were rodent-shaped and probably were doing things that were similar to rodents. Rodents aren't even the first group that did rodent best.
Yes, much like crocs.
Yes, multituberculates not only lived like rodents, but they were successful like rodents before rodents actually came in and took over.
Absolutely.
Which is very cool.
But that's all we got to say about that, because this isn't a multituberculate episode.
It is not this episode is not a lot of other episodes.
Yes.
That's a running theme in this episode.
Absolutely. Once we finish doing all the other episodes, this episode isn't. 40% of our episodes will be rodent episodes.
As it should be, I guess.
We are about ready to wrap up this discussion in this episode. There's a lot, but hope you all enjoyed. Before we go, we have one last section, which is our patron question. Every episode, we like to answer one of the questions our patrons at certain levels can ask us and discuss it here on the podcast for you. David, what's our question today?
This question comes from Jennifer, who asks, what are some consequences that could come from de-extinction? And what consequences could apply to recent extinctions, like quaggas and dodos, versus more distant extinctions, like mammoths?
Very good question.
We did a whole episode about de-extinction back in episode 35.
Yes.
So de-extinction, the idea of engineering species that have gone extinct to be back in the real world.
Somehow bringing them back, quote unquote.
This gets a lot of headlines these days because there are a number of initiatives out there that are claiming to be aiming to bring back thylacines or passenger pigeons or mammoths or whatnot.
Yes. It's also important to note that typically de-extinction projects that are discussed, even if they're not underway, are not talking about it in like the Jurassic Park sense of we're going to just clone and copy that fossil animal, but breed or through genetic manipulation, get an animal that is very similar and shares a lot of genetic traits with.
Right. Create an off-brand thylacine.
Yeah.
Right. We're basically creating an artificial version of whatever that species was.
Exactly. This is a highly discussed but also controversial topic, especially among paleontologists like ourselves and conservationists.
Yes, there's a lot of controversy surrounding the question of whether it's even possible.
Yes.
And then the question of whether it's a good idea.
Absolutely.
And the reason that it's a big question whether it's a good idea is because of the potential consequences of doing it.
There is the forward-facing issue that, and this falls under a consequence, but it's more just an inherent potential flaw, is if you're trying to de-extinct an fossil animal so that we could like learn about that fossil animal, that inherently, at least is the opinion of many people, ourselves included, is impossible because A, you won't know whether you got it right. B, it's an artificial scenario, so it's not the same environment, it's not the same conditions, so you're not going to be necessarily learning. So we will never be able to know whether the info we get off of this created organism would be accurate to the fossil organism and how they once lived.
Yeah. As far as the consequences, if it was done.
Yes.
What are the consequences? The consequences that are typically discussed, I think, tend to fall into three categories, which is the consequences for the environment.
Yep.
Which is the ostensible goal here.
Yeah.
Is to put back a piece of the environment that is missing.
Yes, to replace a member of an ecosystem that we've lost, and maybe an ecosystem, to recreate an ecosystem that has been lost.
This is a species that was doing an important job in the ecosystem that now that ecosystem is incomplete, which is a potential positive consequence if it works properly.
Yes.
The potential negative consequence for the ecosystem is that this is now an invasive species.
Yeah.
That the ecosystem has moved on since it was gone, and now that's going to disrupt ongoing ecology.
Yeah. And that could be the fact that if this organism is brought back and then starts doing the job it was once doing, it's going to disrupt new patterns that have formed since it went extinct. Or, as often happens with animals when we try to bring them places, it doesn't do the job it once did because the game field, the playing field is different, and it starts doing a new thing we didn't know it would do, and causes, that's the cane toad situation of, you'll eat all the cane grubs, and they go, no, we won't, we'll eat everything else.
Well, and this is part of why proposals for Pleistocene rewilding, de-extinction in North America, get a lot more traction when you talk about doing it with mammoths than when you talk about doing it with American lions.
Yeah, absolutely. Like, we should have multiple big cats running around.
Yes. Something's got to eat those mammoths. There's also consequences to the animals themselves.
Yes.
And this is one of the biggest areas where the discussion turns to negative consequences.
The ethical side of it.
Yeah. Which is that if you're bringing back, especially because we talk about so much with mammals, those are social animals. Mm-hmm. So you are engineering a lonely creature
Absolutely.
that has nothing to raise it. And then another consequence that I've never really dwelled as much on this one, although I think that it is a valid point, is the potential consequence to society.
Yep.
I have seen a number of scientists and ethicists point out that if we popularize the notion that we can just bring species back from extinction, will that make us as a society less concerned about our impact on the environment?
Yeah, more cavalier.
When you tell people, well, you have to take care of the surroundings because otherwise, this frog is going to go extinct.
Yeah. Do you want to lose all the polar bears?
Are we engineering a situation where people are just going to go, we'll just bring them back?
Yeah. We'll just make a new one. It's the X-Men comics when they form their resurrection chamber and death no longer has a meaning. Yeah. Are we teaching a bad lesson by doing this? And that's one of those weird ones where it's I can see both sides of that argument of
Sure.
But that could also be said about like a lot of medicine of like if I figure out a way to cure heart disease that was caused by you not taking care of yourself the rest of your life, does that just encourage people to not take care of themselves? It's like, yeah, but that doesn't, should we not cure heart disease? Like, what are you saying?
Right.
So it's got that double-sided, but it is a factor that has to be addressed.
As it stands now, I think that the question of the consequences of de-extinction is the big question. And part of the big sort of controversy around it is the discussion of whether or not there are any legitimate positive consequences, and whether those potential positive consequences outweigh the potential negative consequences. I think that already discussions about de-extinction have consequences.
Yes.
I think the popularity of this topic of conversation already has had consequences on the way that people think about science and the way that people think about our relationship to the environment.
Yes. You also mentioned how would it differ between recent and more ancient ones. And that does bring to mind that the overall idea of de-extinction, when you break it down to its base parts, is really a gradient. There's the full-blown, like, mammoths, which have been gone for a long time, and no living human has ever seen one alive, and we struggle to fully understand them because of how distant they are, to recent extinct stuff like the Tasmanian wolf, the thylacine, that we definitely killed off because people were getting paid to kill them. Mm-hmm. But there's also, like, another category of extinct is extinct in the wild. There's tons of animals that are still alive today, but only in human care. Their wild populations have been utterly destroyed because either their habitat's been destroyed or their population was so low we were worried they would go extinct without our intervention, so we went and gathered them up. Those rewilding processes, we have had moments where we've bred them in human care and then released them back, and now there's wild populations again. Mm-hmm. That's de-extinction in the basest of forms.
Right. And usually that's something where it's like, this species has been absent from this ecosystem for a number of decades.
Yes, exactly.
Or something. So that niche is still potentially there.
Yes.
And even then, we often end up with problems.
Yes, absolutely.
Right. Those reintroduced species might bring diseases back out into that ecosystem.
They might not be ready. There's the story where a bunch of red wolves were released and just got eaten by alligators because they did not know how to handle alligators.
So, arguably, the farther back in time you're reaching, the less likely it seems to work. Not only because we have less material to work with, but also because the environment has changed more.
Yes.
In that time.
It also, and this is a much bigger topic than we can really go over here.
Episode 35. We did a whole episode about it.
But you also run into the whole issue of this is very much in line with some other issues that come up in just conservation mentalities of very often a lot of phrasing and discussion that surrounds conservation topics is we need to maintain or get nature back to the healthy way it's supposed to be. But that idea is inherently flawed because there's not a supposed to with nature. Nature just is. There's not a plan, there's not a diagram, there's not a game plan. There is no correct, quote unquote, way nature should be functioning. There's the way it was before we made cities, and there's the way it is now that we have made cities. And that's often what people mean is before and after, humans being good before, bad after. And I don't necessarily disagree with that, but the idea that to fix things, we have to get it back to some idealized standard it really only works in the short term. Because, but what if an animal starts to go to extinct naturally? Do we conserve it, or do we just study it aggressively before it goes away? De-extinction falls into that same mentality of that idea is inherently pushing the message that before the Ice Age is how the planet was supposed to be when mammoths were here. All right, but it's not then anymore. Maybe we're just an Earth without mammoths now. Yeah.
Fascinating question. If you want to hear us talk more about all of these things, episode 8, which was about conservation paleontology, and episode 35 about de-extinction, and also probably every one of our end-of-the-year Q&As that we've ever done.
Oh, yeah.
I bet this has come up in all of those.
Yes.
So, great question. Thank you, Jennifer, for asking it.
Absolutely. And with that, we're going to end the episode. This was a long time coming.
Yeah, it sure was, and it still is.
Oh, yeah. Part of the reason this one happened is because we were driving and the point came up that, yeah, we haven't done rodents. I went, oh, yeah. Hope you all enjoyed. If we skipped your favorite group of rodents, that was on purpose.
Yes, you specifically.
Yes.
We didn't want to do it.
We skipped it.
Submit requests for whatever rodent-related topics you want us to hit in the future. There is the topic request form on our website.
This was just to cover the idea of rodents. Specific rodents will have their time. Check out the blog for links and pictures. You can learn more about this awesome group. Don't forget, we are getting toward the end of October, so Spooky is starting to wrap up. Don't forget the live stream next month, November 9th, so check in then if you want to talk more about spooky and speculative evolution. We're also getting toward the end of the year. Next month's November, Q&A coming up, so keep an eye out for the questionnaire form.
The questionnaire should be up on the website very shortly after this episode goes up, so submit your questions for 2024.
Thank you to everyone who requested our topic today, and thank you again to all of our new patrons who have joined us.
And our old patrons. And especially to our top-tier patrons, Sarah May, Daniel the Bug Lover, Robert Mart, and Melissa Barksdale. We release episodes every fortnight. We sure do.
And that's all I've got to say about that.
Squeakin'.
Bye.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.